Alright everyone, welcome to this video going through the Year 12 holiday homework. So we've got these selected questions that I'm going to feature and explain. If you have any questions about a particular process, please email or leave a comment. I'll try and be as precise as possible whilst going through it. So we'll get straight in. I've gone ahead and circled the ones that we need to do, and I'll answer these on some paper here. So the first one says, find the equation of these lines. So the equation of a line, we're going to go for y-intercept form. Y is mx plus c, where m is the slope and c is the y-intercept. So if we look at question 1a, we're told both of those. We have the y-intercept is c and the slope is 4. So that means we're going to have y equals 4x plus 3. All right, c is the y-intercept, m is the slope. Very good. Let's move on to c then. And in question C, we have a y-intercept of 4. So we've got the c value ready, but we don't have the slope. We need to determine the slope. So the slope, m, is the change in y divided by the change in x. Or if we have two sets of coordinates, y2 take y1 on x2 take x1. Now we do have two coordinates here. This is sort of the foolproof procedure I get everyone to think about. The first coordinate is x is 0, y is 4. And the second coordinate is x is 2, y is 10. So the slope then, now it doesn't matter what we call y2 and y1 and so forth, as long as the subscripts correspond with the same coordinate. So let's call this x2 and y2, and this will be x1 and y1. And so we'll go y2 take y1. We're going to have 10 take away 4, going from the slope formula here, divided by x2 take away x1, 2 take away 0, 10 take away 4 is 6, and then 2 take away 0 is 2, and so this will simplify to 3. The slope of this line then is y equals 3x plus c, that's y equals mx plus c, and we're already told the y-intercept is 4, so we will have y equals 3x and then plus 4. Alright, so that's our solution for question 1c. Let's move on to 1e. And so if we have a look at 1e, we're given the equation of this line, all right? This line is 2x plus y equals 1. So if I have that, 2x plus y equals 1, I can rearrange it to be y is minus 2x plus 1. Okay, I'm subtracting 2x from both sides. I'm moving the 2x over here. And so we can see the slope of this line then is minus 2. The slope of this line is minus 2. That's what I've stated there. Now, we're told the line we need to find is perpendicular to it. It's perpendicular to it. And so remember, if a line has slope A on B, then a perpendicular line has slope negative B on A. All right? So our line here has a slope of minus 2. Now, as a fraction, that's minus 2 on top of 1. So that means the perpendicular line, when we perform what we call the negative reciprocal of it, we're going to flip it, so that makes it half, and multiply it by minus 1. So at the moment we have negative, and when we multiply it by negative 1, it becomes positive. So for negative reciprocal, it's just, if it's negative, it becomes positive. If it's positive, it becomes negative. And all you're doing is flipping it. So our new line then has a slope of half. This line here that we're asked to find has a slope of half. So we'll start that off, y equals half x plus c. We need to determine the y coordinate, the y-intercept. Now the y-intercept occurs when x is 0. That's not particularly useful to us, but we're going to use one of the coordinates we're given. Let's use this one. We've got when x is 10, y is 1. So we're going to plug that into this equation we've started to develop. We're going to put 1 where the y is, and we're going to put 10 where the x is. Process this for c. Half of 10 is 5, and then c has to be minus 4. We subtract 5 from both sides. We'll have minus 4 is c, and so therefore the equation of this line is half x take away 4. All right, so we were given the equation of that one. We found the equation of the perpendicular line by doing the negative reciprocal of the slope. All right, so that's question 1e. Let's move on to question 1f. And in question 1f, we've got two lines to find. I've called them L1 for line 1 and L2 for line 2. So if we look at line 1, let's do that first. Remember, we need the slope. So it has the equation y equals mx plus c. We need the slope. Now remember, slope is change in y divided by change in x, or you can think of it as those two coordinates. You can use those if you want, but it's much easier to just process it like this. We can see it's gone across 6 units and up 2 units. So the change in y is 2, the change in x is 6. Now this will simplify to a third. So line 1 has a slope of a third. So line 1 is going to be y equals a third of x plus c, and we're even given the y-intercept here. We can see the y-intercept is minus 2. So it's plus minus 2. We don't need to write plus minus 2, we just write take away 2. A third of x take away 2 is the equation of line 1. Let's move on to line 2. Now we're told via these arrows that these lines are parallel. Now what that means is these lines have the same slope. They're going in the same direction. So that means line 2 is also a third x plus c, but we can see it has a different y-intercept. So we need to determine that value. We do know that line 2 goes through 1 and 11. So that means when x is 1, y is 11. So let's plug that information in. We're going to put 11 where the y is, and we'll put 1 where the x is. In order to get c by itself, we'll subtract a third from both sides. All right, and 11 take away a third. You can put that in your calculator if you want to, but I want you to be very competent at these fraction operations. In order to process this, that you need to make these have the same denominator. So that's going to be 11 with a denominator of 3 is 33 divided by 3, right? 33 divided by 3 is 11, and we have 33 on 3 take 1 on 3. They have the same denominator, so we can now process that. 33 take 1 is 32. 32 on top of 3. So the equation of line 2 then is a third of x plus 32 on 3. And you can express it as a decimal if you want, but we tend to prefer fractions at stage 2 level. All right, so that's question 1. We've gone through A, C, E, and F. Let's move on to question 2. Pretty similar here with question 2. I might just pause and sharpen my pencil quickly. Okay, I'm back. Sketch the graphs of each of the following lines and find their equation. Okay, so we have a line parallel to the line 3x plus 4y equals 4 with y-intercept minus 1. So let's rearrange it first to find the slope. It's parallel, so that means this line and our line have the same slope. So I'll take this line first. So this is question 2e. We have 3x plus 4y equals 4. So if I'm going to rearrange it, I want to get y by itself so that it's in y-intercept form. The first thing I'll do is subtract 3x from both sides. So I'm moving that term over here. And then what we're going to do, we want y by itself, so we'll divide both sides by 4. So it would look like this, minus 3x plus 4 on top of 4. And then what we can do is split the denominator, so that applies to both terms. We have minus 3 on 4x, and 4 divided by 4 is 1. All right, so I've split the denominator belongs to this term, and it belongs to this term. And so what we can see, this is the equation of the line we're given, but the point is it has a slope of minus 3 on 4. So that means the line that we're going to sketch then, so this is the line, it has a slope of minus 3 on 4, but it has a y-intercept of minus 1. So that means our c value is minus 1. We're going to sketch the equation of this line. All right, so I've got some graph paper here that I'll do it on. So the first thing is it has a y-intercept of minus 1 and it has negative slope. So I'll just do it such that I'll just sketch a Cartesian plane here. And let's sketch it a bit out like this, and we'll just say minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. That's probably enough for now. 1, 2, minus 1, minus 2. That's plenty. Minus 1, minus 2, minus 3, minus 4. All right, so you get the scale from it. Now, we have a y-intercept of minus 1, so that's here. and we have a slope of 3 on 4. Now remember, slope is change in y divided by change in x. So we have minus 3 on top of 4. That means we go across 4 spaces. X goes across 4, 1, 2, 3, 4, and down 3 spaces. 1, 2, 3. So that would be the next coordinate. And then once we've got two points, if we draw a straight line through them, that's going to be the line that we're required to graph. That is the line 3 on 4, minus 3 on 4x, take away 1. It's got negative slope. Very good. So that's question 2. Let's move on to question 4. Okay, use the same axes to draw accurate graphs of. Firstly, we have y. I'll use this paper because it's grid. The first graph we have is y is 3 take away 2x. Now you can write it like that if you want, or you can write it like this, minus 2x plus 3. Like this is useful because it tells us the slope, right? Don't get confused. The slope is always the coefficient of x. That's the first graph. And then here's the second one. 3y plus 2x is 4. It's in general form. Let's show you a really cool way to sketch graphs in general form. Firstly, the x, all you need is 2 points, right? We can find the x-intercept. The x-intercept when y is 0. So if the x-intercept occurs when y is 0, that means this component is 0, and we have 2x is 4. So if we have 2x is 4, then we would have x, we'd divide both sides by 2, we have the x-intercept is 2. Similarly, the y-intercept occurs when x is 0. Like if you look at this graph here, here's our y-intercept. What's the x value? 0. Here's our x-intercept. What's the y value? 0. So the y-intercept is when x is 0. And if we process this, if we have x is 0, we cover that up. We would have 3y equals 4. Divide both sides by 3. We have y is 4 on 3. And 4 on 3, that's the same as 1 1/3, right? So we've got both of those points. All right, let's sketch these graphs. So I'll draw a decent sized Cartesian plane here. And we'll have the same kind of scale. Maybe I'll put that down here. All right, so where we have, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so if we have the line in general form, it has an x-intercept of 2, so that's here, and it has a y-intercept of 4/3. So that means 1 1/3, all right, as a mixed number, 1 1/3. So here's 1, and here's about 1/3 of 1. That's the y-intercept. So once you have 2 points, remember, you can just draw a line straight through them. So that will look like this. So that's the equation of our line in general form. And whenever we sketch a line, we must label it. This is the line 3y plus 2x equals 4. And then we have this line as well. Y is minus 2x plus 3. So if we look at this line, it has a y-intercept of 3. So 1, 2, 3. Here's its y-intercept. And it has a slope of negative 2. Now remember, slope is change in y on change in x. And so we have negative 2. And what's the denominator? Negative 2 on top of 1. So it means it's going across 1, down 2. So we go across 1, down 2. Across 1, down 2. So that's going to be the minus 2x plus 3. So yep, y-intercept of 1, 2, 3. And we're going across 1, down. I only went down 1. That's why that's not working. Across 1, down 2. Across 1, down 2. All right, and we can draw a line through these as best as we can. That's the equation of our second line, which is y is minus 2x plus 3. So across 1, change in x is 1, change in y, negative 2. Very good. So that's part 4A done. Use the axes, draw accurate graphs. They're pretty accurate. All right, use the graphs to estimate where the lines meet. Where do they meet? Well, they meet here. Okay, so what are the coordinates of that point? Well, this is x is 1 and this is x is 2. So the x value is about 1 1/3, maybe 1.25. Let's put 1.25. The y value where they meet is about half, okay? Here y is 1, so the y value where they meet then is about 0.5. That's going to be my guess for part B. All right, that's my guess for part B. Now, let's answer part C. Use algebra, find the exact point where they meet. So let's get rid of this. Let's make a bit of space. So the equations we had minus 2x plus 3, that's the first one. And the other one we had was 3y plus 2x is 4. Now there's a number of ways to do this, all right? But I think the most intuitive way that we've done a fair bit before is to express both in y-intercept form and then equate them. So let's subtract 2x from both sides. All right, we're seeking to get the y term by itself. Divide both sides by 3. We'd have y is 4 on 3, take away 2 on 3. I'm skipping a few steps. Let me be a bit more precise for you. So the first thing we can do even then is rewrite it like this, minus 2x plus 4. Now we can divide both sides by 3. So we have minus 2x plus 4 on top of 3. And we can leave it like that, or we can even split the denominator if you want to. I'm going to leave it like that for now, because see how we've got y and we've got y? We want to know when they meet, when they're the same. And so that means we're just going to equate both of these equations. We have minus 2x plus 3 is equal to minus 2x plus 4, all on top of 3. So if we want to solve this equation, the first thing we're going to want to do is get rid of any denominators. Now we've got this 3 at the bottom. I'm going to multiply both sides by 3 in order to get rid of it. Remember, you can do anything you want to an equation as long as you do it to both sides. So here we'll have 3 at the top, 3 at the bottom. That will cancel. Over here we'll have minus 6x plus 9. That 3 is going to distribute there. And on this side we're going to have minus 2x plus 4 because the 3 is cancelled. Now we want to get the x's on one side and the numbers on the other. So I'm going to plus 2x to both sides to move this over. All right. I'm going to plus 2x to both sides and I'm going to subtract 9 from both sides in the same step. So when I plus 2x to both sides, this will cancel, and over here we'll have minus 4x. Minus 6x plus 2x is minus 4x. I'm also going to subtract 9 from both sides. So that will cancel, and over here we'll have 4 take away 9, we'll have minus 5. In order to get x by itself, we would divide both sides by negative 4. And so negative 5 on negative 4, we have the x value is 5 on top of 4, which is, as we predicted, the same as 1.25. So we've got the x value. Now we need the y value where they meet. This is the x value where the functions are equal to one another. In order to determine the y value, we can just input it into either equation. Both are going to have the same corresponding y value. So here we have y is minus 2x plus 3. Let's put that x value in. We'll have y is minus 2 times 1.25 plus 3. This is going to be minus 2.5 plus 3, and we get 0.5. So the coordinates where these two functions meet then are 1.25 and 0.5. And you can check that on your calculator, right? Like if I just go into the graph mode, let's set this as minus 2x plus 3, and the second equation was minus 2x plus 4, all on top of 3. Just set our V window to standard quickly. All right, maybe going a bit fast. Shift V window, set it to standard. That's the standard operating procedure. We can see both lines that we've already sketched, and we can G-solve the point of intersection. It's going to be that same coordinate. That's going to confirm what we've seen here. Excellent. So that's enough of linear equations. Let's move on to some quadratics then. So we've got some expansion to do. We've got question 5 here. And we're starting with minus 2x multiplied by 5 take away x. We're just going to do the distributive law. Minus 2x times 5 will be minus 10 lots of x. And then minus 2x times minus x will be positive 2x squared. Okay, the negative times the negative becomes positive, and x times x gives us the x squared term. So that's A. Let's move on then to D, where we have x plus root 7 multiplied by x take root 7. Now, whenever you see something like this, it's difference of two squares, right? We have a plus b times a take b. It's always going to simplify to a squared take b squared. So, I mean, if you want, you could do like a FOIL kind of thing, but you don't need to. It's a plus b times a take b, which means it's going to simplify to a squared take away b squared. Now, we'll just write that more simply. Root 7 squared is 7. So that's D. Let's move on to G, G is x plus 6 times x take 6. Exactly the same thing. Difference of two squares. We're seeing a plus b times a take b. A squared take b squared, which is x squared take 36. Very good. And then we've got J. We have 2x plus 1 multiplied by 2x take 1. All right, a plus b times a take b, but this time 2x, that whole term is the a term, right? So it's going to be a squared take b squared, and 2x squared, we're going to square both the 2 and the x. That becomes 4x squared take away 1. Okay, so here it's factorized, here we've expanded it. And again, you can do some FOIL there if you want to. All right, and then we're on to m. All right, good. M is a good one. We have 1 take away 3x plus x plus 2 squared. So here there's nothing to expand there, they're already expanded, but over here we're going to use the perfect square rule, right? We have a plus b squared. A plus b squared is a squared plus 2ab plus b squared. So you have to, I'll write it out like this underneath it. A squared plus 2ab is a squared plus 2ab plus b squared. So a corresponds with x, right? So we'll have x squared plus 2 lots of the a term times the b term. All right, so a corresponds with x, b corresponds with 2, x squared plus 2 lots of x times 2, and then plus the b squared. So let's write what we've got having done that expansion. 1 take 3x, that's the first component, and then we have over here plus x squared plus 2 times x times 2, that's going to be 4x, and 2 squared, that will be 4. So when you expand this using the perfect square rule, this is what it becomes. And then all we're going to do is collect like terms. I'm going to write the x squared at the front. It's the leading term, it being the highest power. We have 1 lot of x squared. We have 4x take away 3x. That leaves us with 1 lot of x. Now, we don't need to write the 1 in front. X by itself insinuates there's 1 lot of it. And then we have this positive 1 and positive 4. And when we collect them, we get positive 5. So that's product expansion. That's M. That's question 5. Move on. We're on to question 6. We're factorizing. All right, very good. Factorizing is one of my favorites. So if we look here, we've got C. We've got 2x squared take away 8. So the first thing we've got, so this is question 6C. I'll fence that off. The first thing here we've got is 2 is very obviously common. So if I pull 2 out the front, this is what it's going to look like, right? X squared take 4. But again, we should be looking at that going, that's difference of 2 squares. I've got a squared take away b squared, right? We could write it like this. A squared take b squared, which means it would factorize to a take b times a plus b. All right, a squared take b squared, a take b, a plus b. Difference of 2 squares, and that 2 is just hanging out the front. We've successfully factorized that into linear factors. Okay, next we're moving on to a monic quadratic trinomial. Now, it's monic because the leading coefficient is 1. So we have x squared take away 2x plus 1. And whilst this is a perfect square, I would like to just talk about how we factorize monic quadratic trinomials first. What we're doing here, we're looking for 2 numbers that multiply together such that their product, when you multiply them, is 1 and their sum is minus 2. So if we think of multiples of 1, it has to be 1 times 1, right? And in fact, it has to be -1 times -1, because -1 times -1 will give you +1, and -1 plus -1 will give you -2. So this is the solution, -1 and -1. So that means we would have x take 1 times x take 1, which we could also write as x take 1 squared. I said it was a perfect square. There's only one solution. So that's how we do monic quadratic trinomials. We say, what are two numbers that we can multiply together to get that, and then add them. Now it's going to pop up a fair bit more in the next few questions. So if you're not sure, let's continue and have a look through them together. All right, so we've got I, and in I we have 2x squared plus 5x take 12. So a little bit harder straight away. You can use the cross method or you can use the slide method. Now, here as well, it's different. This is what we call non-monic because the number out the front is not 1. Monic if the number out the front is 1, non-monic if it's not 1. And these are a fair bit harder. Now, I think the best strategy for this is we take that 2 and we slide it over here. We multiply it over there. So this is going to become x squared plus 5x take away 24. And now it appears to us as a monic quadratic trinomial, right? We're looking for two numbers whose product is minus 24, and when you add them together, you get positive 5. So you think about multiples of 24, right? 1 times 24, 2 times 12, 3 times 8, 4 times 6. So all the factors, one of them has to be negative, and we have to add them together to get 5. It's going to be negative 3 and positive 8. Negative 3 times positive 8 will give you minus 24, and minus 3 plus 8 will give you positive 5. Okay, so that's how we're going to factorize that quadratic trinomial. So what this will become, we've said negative 3 and positive 8, so it becomes x take 3 and x plus 8. But what about the 2? All right, we've got 2 here, so that means we need to divide through by 2. Now, can we divide this one by 2? No, we can't. Can we divide this one by 2? Yes, we can. So because we can't divide this term by 2, that 2 comes up here. So we'll have 2x take 3 as the first factor, and this one we can divide by 2, it becomes x plus 4. And so we've successfully factorized that non-monic quadratic trinomial. All right, so quite a tricky process. Let's move on, and we'll just keep doing them. And if you're finding it hard, it can be a skill I mean, there's more here to practice. Just try follow the process. It can be one we work on together as well. All right, so we just did I. Let's move on to L then. In L, we have 6x squared, take away x, take away 2. So let's use the slide method, slide the 6 over. We're going to have x squared, take away x, take away 12. We're looking for two numbers that multiply together such that their product is minus 12 and their sum is minus 1. All right, so products of 12, we're thinking 3 and 4, 2 and 6, and you can see these have a difference of 1, and we want the 4 to be negative. Okay, 3 times negative 4 will be minus 12, and 3 take away 4 will give you the negative 1. When you combine them, you get negative 1. So that means it becomes x plus 3 and x take away 4. How about the 6? Can we divide it by 6? This term can't, and neither can this term. But both of these fractions can be simplified, and we simplify them as much as we can. 3 on 6 is firstly the same as 1 on top of 2. It's half. And similarly over here, 4 on 6 is the same as 2 on top of 3. And now we're going to take that number up the front of the x here. We have 2x plus 1, and we'll have 3x take away 2. So that's how we factorize this one. All right, and I think we'll squeeze the last one in here. We have for O, we have 12x squared, take away 16x, take away 3. Using the slide method again, multiply the 12 through. That would give us x squared, take 16x, take 36. Now, multiples of 36. 36 is a beautiful number. There's lots. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. There's heaps of factors in there. All right, so we're going to go with one of them has to be negative, negative 18 and positive 2. All right, negative 18 times 2 gives you negative 36, and negative 18 plus 2 gives you the negative 16. So two numbers whose product is minus 36 and adds to minus 16. So I said x take 18 and x plus 2. Now we have to divide through by 12, don't we? So we have that one on 12 and that one on 12. In simplest terms, 18 on 12 is the same as 3 on 2, and 2 on 12 is the same as 1 on 6. And we'll move the 2 up the top there. We'll have 2x take away 3, and here we'll have 6x plus 1. Fully factorized O. Very good. All right, so that is L. Let's move on then to question 7. Factorize into linear factors. So in question 7, we have the first one, x plus 5 squared plus x plus 1 multiplied by x plus 5. Okay, so if we're looking along here, we can see this term has x plus 5 and this term has x plus 5. X plus 5 is common to both of them, so let's pull that x plus 5 out the front. So we'll have x plus 5, I'm pulling one of them out the front, and so if I pull x plus 5 out the front, we're left with one lot of x plus 5 in this term, and we're left with x plus 1 in this term. All right, so you got to think, if I expand that, if I distribute the x plus 5, we'll get the squared, and we end up with that term. That's how we factorize it. And then looking in here, there's nothing multiplying, we're just adding them, so we can collect that. And what we'll have in here, x plus x, that gives you 2x, and 5 plus 1, that gives you 6. So 7a, here's what it factorizes to. Okay, let's move on to E. We've got x plus 3 squared, take away 4. Now I'm seeing a squared, take away b squared. We've got our difference of two squares again, right? A squared, take away b squared. That becomes a plus b times a take b. All right, a plus b, a take b. And simplify those, that's going to become x plus 5, and this one will become x plus 1. So that's 7a and E. All right, move on to question 8. Now we're doing a bit more of our quadratic trinomials here. We have solve, we've got question 8, we've got E, which is x squared plus 3x is equal to 4. Now, whenever we're solving a quadratic equation, we want to get everything on the left-hand side. So we'll have x squared plus 3x take 4 is 0. We're looking for two numbers that multiply together to give you minus 4. So product is minus 4, and the sum is positive 3. And so that's going to be positive 4 times negative 1. Positive 4 times negative 1 gives you negative 4. 4 plus negative 1 gives you 3. So wrapping the brackets around, we'll have x plus 4 multiplied by x take 1 is 0. We apply the null factor law. If we have a times b is 0, either a is 0 or b is 0. Here we get x is 1, here we get x is negative 4. All right, so that's 8e. We've got 8g to do as well. So here's 8g, and we've got 3x squared is equal to 4x plus 4. All right, so I said let's get everything on the left-hand side. 3x squared, take 4x, take 4 is equal to 0. So taking both of those from both sides. Let's perform the slide method. So we can make it x squared, take 4x, take 3 times 4 is 12. Okay, multiples of 12 that add up to 4. So we need two numbers whose product is minus 12 and whose sum is negative 4. That's going to be, if we think of multiples of 12, 1 and 12, 2 and 6, 3 and 4, has to be this one with a negative 6. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So we're going to have x take 6 and x plus 2. And then what about the 3? Well, we divide by 3 and we divide by 3. So this term becomes x take away 6 divided by 3 is 2. So we don't need to move the number up the front there. This one we can't divide, so we'll move the 3 up there. 3x plus 2 equals 0. Now we're applying the null factor law, right? Either x take 2 is 0 or 3x plus 2 is 0. Okay, this gives us 3x is minus 2, x is minus 2 on 3. And this gives us x is positive 2. So subtracting 2, dividing by 3, and then just adding 2. These are the two solutions that satisfy this equation. Both of those numbers make it true. So that was 8g. And then we've got question 9. We've got all of question 9, so there's a fair bit involved in question 9. All right, what we've got is we've got the first one, find the points of intersection of the following functions, check using a calculator. So our first function is x plus 1 squared, and our second function is minus x squared plus x plus 4. Now I'm just going to pause for a moment and get a drink. Alright, so the way we find the point of intersection between two graphs is we just make them equal to one another. So we'll take the left hand side, we have x plus 1 squared, and on the right hand side we have this term minus x squared plus x plus 4. So if we're going to find when they're equal to one another, we're going to need to expand it and move everything onto the left hand side. So here's a perfect square, x squared plus 2x plus 1, assuming we know how to expand the perfect square, or you can use FOIL if you want. And on this side, minus x squared plus x plus 4. So if I want to move these three terms to the left hand side, what we need to do is add x squared to both sides. We need to subtract x to get rid of that there, and subtract 4. So on this side, I'm going to add x squared. That's going to give me 2 lots of x squared. I'm subtracting 1 lot of x, so it's going to give me just x. And then I'm subtracting 4 from both sides as well. That's going to give me 1 take away 4 will be minus 3. All right, so this is the quadratic then that we're finding solutions to in order to find when they intersect. So we've said they're going to intersect here, and then this maintains the same relationship throughout. So then what we're going to do is we're going to, again, use the slide method. So I have x squared plus x take away 6, multiples of 6 that add up to positive 1. That's going to be x take 2 and x plus 3. Okay, minus 6, and then leaves us with plus 1. And then we need to divide through by 2. So we'll divide by 2, divide by 2. This becomes x take 1, and this becomes 2x plus 3. As far as our solutions go, so we'll make it, we're finding when it's equal to 0, and applying the null factor law, we have x take 1 is 0, or 2x plus 3 is 0. This gives us x is 1, or over here we'll get 2x is minus 3, we'll get x is minus 3 on top of 2. So they're the two x values when they meet. We need the y values as well. Well, they're going to have the same y values, so it doesn't matter which one we put them into. This one will be a bit easier. So we have when x is 1, y is 1 plus 1 squared. I'm putting the x value right there. That's going to be 2 squared, which is 4. So the first coordinate where they meet is x is 1, y is 4. And the other coordinate is x is minus 3 on 2. Let's put in x is 3 on 2. We're going to have y is minus 3 on 2 plus 1 squared. That's minus 1.5 plus 1. That's minus half squared. And that's going to be positive 0.25. All right. So we can use our calculator to support us. But it did say to check on your calculator, right? So what I'm going to do, hop out of here, I'm going to sketch both of these functions. We have x plus 1 squared, and we have minus x squared plus x plus 4. Graph both under standard V window, and we can press G solve, intersection. So the first coordinate, minus 1.5 and 0.25. The second coordinate, 1 and 4. So both of those are satisfied. You can express minus 3 on 2 as minus 1.5. Either of those is absolutely fine. So that was 9a. Let's move on then to 9b. Now in 9b, we have our first function. So 9b, we have our first function is 6 multiplied by x take 1 on x. And our second function is the line y equals 5. Now, I've said if we're going to find when they meet, we just have to make them equal to one another. 6x take 1 on x is equal to 5. Now, first thing, let's just distribute this 6. So we'll have 6x take 6 on top of x is equal to 5. And now we've got this x as a denominator, and we can't have that at all. So we need to multiply both sides by x in order to get rid of that denominator. So when I multiply both sides by x, this term becomes 6x squared. This term is going to become take away 6 because you have x at the top and the bottom, so it will cancel. And that way we've gotten rid of the denominator. And on the right hand side we have 5x. Remember, you can do anything you want as long as you do it to both sides. Here we want to get rid of that denominator, so we multiply both sides by x. So we've got this equation. Let's take away the 5x from both sides. So I've moved this 5x onto the left hand side, and we're going to go through and solve this one. Using the slide method, x squared take 5x take 36, so multiples of 36 that add to negative 5. There's lots of multiples of 36. It's going to be minus 9 and positive 4. So we'll have x take 9 and x plus 4, and we're dividing through by 6, right? So we'll have on top of 6 and on top of 6. Now, 9 divided by 6, the simplest that becomes is 3 on 2, and x plus 4 on 6, the simplest that becomes is 2 on top of 3. So we have 2x take 3, and we have 3x plus 2 is what it factorizes to. Now we can apply the null factor law. Either 2x take 3 is 0, in which case 2x is 3 and x is 3 on 2, or 3x plus 2 is 0, in which case 3x is negative 2, x is negative 2 on top of 3. So subtracting 2, dividing through by 3. So we've got the x values, we need the corresponding y values. And I've said we can put it into either equation. Now this equation always has y is 5, which means the points of intersection are going to be 3 on 2 and 5, and minus 2 on 3 and 5. It doesn't matter what the x value is, the y value is always 5. And we can see that when we sketch both of these functions. 6 times x take 1 on x, that's our first function. Our second function 5. G solve the points of intersection. So first one here, 2 on 3 is the same as 0.6 recurring, and it's negative, so we have negative 0.6 recurring in 5, and then 1.5 and 5 for our other coordinate as well. So both of those viewable on the graph. All right, last one then before we get to question 10 is 9c, and we have here y equals 6x take 1, and we have y equals 10 on top of x take 2. So step 1, make them equal to one another. Looking on the right hand side, we have this x take 2 denominator. We can't have that, we need to get rid of the denominator, so we're going to multiply both sides by this denominator. Now what this does, okay, we have x take 2 at the top, x take 2 at the bottom, it cancels. Alright, we'll expand the left hand side here using FOIL. We'll have 6x squared, take away x, take away 12x plus 2, and on the right hand side we have 10. Collecting over here, 6x squared take 13x. Now we've got 2 and 10, we're going to move the 10 over, so we have 2 take away 10, that's going to leave us with minus 8. Alright, so we've got this quadratic that we need to solve now. Using the slide method, we'll have x squared take 13x. Now 6 8s are 48. Now multiples of 48, it's going to be 16 and 3. They're quite tricky ones. Remember, you can use your calculator to help you out with solving quadratic trinomials as well. So we'll have x take away 16 and x plus 3. And we need to divide through by 6, don't we? So we have on top of 6 and on top of 6. Now the simplest way to write this, we can divide both by 2. So that would leave us with x take away 8 on top of 8 on top of 3, and this one is x plus a half, and so this becomes 3x take 8, and this one becomes 2x plus 1. Okay, now we can apply the null factor law. Either 3x take 8 is 0, in which case 3x is 8, in which case x is 8 on 3, or 2x plus 1 is 0, 2x is negative 1, x is negative half. We need the corresponding y values, so let's put them into the first one. When x is 8 on 3, y is 6 times 8 on 3, take away 1, That's 48 on 3, take away 1, that's 16, take 1. The y value is 15. So our first coordinate then, 8 on 3 and 15. And our second coordinate, when x is minus half, y is 6. I'm putting it into this equation. 6 times minus half, take away 1. So that's minus 3, take 1, that's minus 4. So we have minus half and minus 4. Check our answers. So 6x take 1 and 10 on top of x take 2. I'm going to have to crank my V window up a little bit so I can see the maximum y1. G-solve intersection. So our first point, minus half and minus 4. That one there. And our second point, 8 on 3 and 15. Alright, so that's question up to question 9 done. I'm going to take a little break and we'll resume shortly with question 10. Alright, so continue. We're on question 10. We've got use the quadratic formula to solve the following. So for question 10a, we have x squared take 4x take 3. Now quadratic formula is minus b plus or minus the square root of b squared take 4ac, all on top of 2a. So if we're using the quadratic formula, we need to identify the values of a, b and c, and those are just the coefficients. So a is the coefficient of the x squared term, we have the number 1 there. B is the coefficient of the x term, which is negative 4, we must keep the negative with it, and c is the value negative 3. So we've got those three numbers and we're just going to plug those straight into the quadratic formula. So the solutions we will get are x is minus 4. Okay, the value of b is minus 4, so we have negative b, negative 4, plus or minus the square root of b squared, take away 4ac, all divided by 2 lots of a. And we'll just process this. Negative becomes positive. 4 squared is 16. 4 times 3 is 12, all divided by 2. So this is 4 plus or minus the square root of 16 take 12 is positive 4. The square root of 4 is 2. And then we have 4 plus 2, or 4 take 2. And processing those, 8 divided by 2 is positive 4. 2 divided by 2 is positive 1. So the solutions are, this is 6. 4 plus 2 is 6. 6 divided by 2 is 3. 3 or minus 1. 3 or positive 1. Okay, on to, now we've got a all the way through to f. So this is an equation that we're going to solve using the quadratic formula. And so we have 2x take away 1 on x is equal to 2. Now whenever we're asked to solve something like this, what we need to do is get everything on one side and we need to get rid of any denominators. At the moment our denominator is x, so I'm going to multiply both sides of the equation by x in order to get rid of the denominator. Alright, we're maintaining equality, we can do anything we want as long as we do it to both sides. Multiplying both sides by x. So now this term is going to become 2x squared. This term is going to become 1 because we'll have x at the top and x at the bottom, and so we've gotten rid of the denominator. And then over here we will have 2x. Move the 2x over, so we'll have 2x squared, take away 2x, take away 1 is 0, and now we've got a quadratic on the left hand side. Alright, identify the values of a, b and c for the quadratic formula. We'll have a is positive 2, b is negative 2, and c is negative 1. Let's plug this straight into the formula. We're going to have minus 2 plus or minus the square root of minus 2 squared. Take away 4 times 2 times minus 1. And all of that is divided by 2a. Alright, and all we're doing with quadratic formula is processing. So minus becomes positive. Here we're going to have the square root of 4. Take away, now we have 4 times 2 times minus 1. That becomes plus 8. Alright, because we have the negative times the negative, which is positive, and 4 times 2 times 1 is 8. And all of that is on top of minus 2. So what have we got? We've got 2 plus or minus the square root of 12 on top of minus 2. Now that's our solutions. It can be simplified a little bit using surd operations. So for instance, the square root of 12, one way we could write that is it's the square root of 3 times 4, which is the square root of 3 times the square root of 4. And the square root of 4 is 2, isn't it? So that leaves us with root 3 times 2, or 2 lots of root 3. So this component, root 12, can be simplified to 2 lots of root 3. So if we simplify that, what we've got, we're going to have 2 plus 2 root 3 on top of minus 2, and 2 take root 3 on top of minus 2. Sorry, there's a 2 out the front there. And we can divide both terms by 2. We're going to have minus 1, minus 1 take away 2 root 3, and we'll have minus 1 plus 2 root 3. So here's fine, but it can be simplified to either of these two using surd operations. So that's question 10. We've done A and F. Let's move on. Now we're at question 11. So we have a graph of a quadratic. I'll clear the page here. We have, for the quadratic, 2x squared take 4x plus 1. Find the y-intercept. Okay, so we're on question 11. 2x squared take 4x plus 1. Now, the y-intercept occurs when x is 0. So if we put x is 0 in here, that's going to be 0, that's going to be 0. The y-intercept is 1. So the yint for the y-intercept is 1. All right, on to part B. Find the equation of the axis of symmetry. Well, the axis of symmetry has the equation minus b divided by 2a. That's for a quadratic, the axis of symmetry. If you think here's a quadratic, the axis of symmetry is the line about which it is symmetrical, and it has an x value minus b on 2a. So in our circumstance, the a value is 2, the b value is negative 4, right? So it's going to be minus negative 4 at the top, and then 2 lots of a at the bottom. So we have minus 4 divided by 2 times 2. Now, negative negative becomes positive. So we have 4 divided by 4, we have 1. The axis of symmetry is x equals 1. Okay, find the coordinates of the vertex. Well, right here we've got the x value of the vertex. Okay, so that means this is the x coordinate of the vertex. We want the y coordinate of the vertex, right? The turning point. And so we're going to take that x value, x is 1, and put it in to determine y. When x is 1, y is going to be 2 times 1 squared. Take 4 times 1 plus 1. Just process this. 2 take 4 plus 1. We'll have minus 2 plus 1, and we'll have minus 1. So the coordinates of the vertex then is x is 1, y is minus 1. Okay, and then lastly, the x-intercepts. So x-intercepts occur when the y value is 0. All right, if you think, just take a random quadratic. Here's the y-intercept, the x value is 0. Here's the x-intercepts, the y value is 0. So what we need to do is make the equation equal to 0. Now this can be one that we can solve using quadratic formula. It can be one that we try and factorize. So we'll just have to have a bit of a wrestle with it and see how we go. Quadratic formula is sort of the foolproof method of it. And the other thing we can do, of course, is use your calculator. And like using your calculator can be, especially if you've got it, it can be good to support to say, oh, can I use, rather than using the discriminant and multiplying that all out, can I use my calculator to find roots for it? We are asked to graph it too. So I'm in graph mode and +1, and I'll delete this. And if I g-solve those roots, okay, we can see they're irrational. All right, see how they've got an infinite number of decimal places here? Oop, I think we're okay. We've got an infinite number of decimal places, which means they're irrational solutions. So there and there. And so the x-intercepts are, like if you use quadratic formula, it'll come out as some root. And if you put the root into your calculator, you'll get 0.292 and you'll get 1.707. So they've asked us to sketch a graph of it. What I'll just point out on the calculator here is if I g-solve that minimum point, you can see the vertex x is 1, y is -1, and it's symmetric about the line x is 1. And if I g-solve the y-intercept, we saw before our y-intercept is 1. That's what we expect. So just to provide a rough sketch of it, here's, it's not very good scale. I'll just up this a little bit. There we go. All right, so that can be y is 1, and then down here we have x is 1, y is -1, and our roots we have a 0.7, what was it, 0.7, sorry, 0.292, 0.293 it will round to, and the other one is 1.71. So there we go, we've answered question 11, provided a rough sketch. Using our calculator in support, we could find those roots using quadratic formula. We're not asked to, so this is all fine. All right, on to question 12. So if we have a look at question 12, we have find the quadratic equation which has this function. So if we look at the first one, we've got roots at x is -1 and roots at 4. So remember, for a quadratic equation, it's going to have the form, one of the ways, if we've got linear factors, is that we can write it like this: x take p, x take q, where the roots are p and q. All right, so if the roots are p and q, our roots are -1 and +4. Okay, now x take -1, that becomes +1, doesn't it? So that's all good so far. That's it as linear factors. However, we need to determine this value of a, this dilation coefficient, right? How much is it stretched? And we know the y-intercept is -8. So that means when x is 0, y is -8. So we're going to plug that information in. I'm going to put -8 where the y is, and I'm going to put 0 where the x is. All right, so we've got -8 is equal to -4a, which means the value of a has to be 2. Okay, so the equation of this quadratic for question 12a is y equals 2 times x plus 1 times x take 4. Now here we have it expressed as linear factors, right? It's one linear factor multiplied by another. So this is in linear factor form. It tells us the roots of a quadratic. If we wanted it in general form, we could expand it using FOIL and distribute the 2, and then we would have some 2x squared term out the front. And that would be the general form of the quadratic. So multiple forms of expressing a quadratic. We also have in example B another way we can express a quadratic, which is where there's one root, where it touches. And so we should remember from polynomials, when it touches the x-axis, that's a squared factor. So the equation of this quadratic then, like if we're going to have x take h squared, where h is the point where it touches, it's the double root, right? And in this circumstance, it touches at 2. So we're going to have x take away 2 squared. And we need to use another piece of information to find the value of a. We've got that y-intercept this time is +8. So we know when x is 0, y is +8. So we'll substitute that in there. We're going to have 8 is equal to a times, we put 0 where the x is. So this is 8 is equal to 4a, minus 2 squared is +4. And so then again, our value of a is 2. The equation of this quadratic is 2 times x take 2 squared. All right, so there's a couple of things involved here. One is determining the roots, and there's two ways in which it can be asked. We've got here the where it touches the x-axis, and we've got here where we've got linear factors where it cuts it twice. So that's question 12. Let's have a look at question 13. Looks like a nice one. Find the value of a given that the graph touches the x-axis at A and the point 1,8 lies on the graph. Okay, so because it touches at A, that means the equation of this quadratic is going to be some dilation. Now I'm going to change that to be, let's call it S. I'm going to use the letter S instead, just because we often put this A number out the front, right? So I'm going to have A times X take away S. We put A out the front as the dilation factor. Now I don't want to have X take A in there and then an a out the front, because these are different variables. Or even if I try and denote it a little bit differently, I'm going to get mixed up between them. So in this circumstance, I'm going to declare that variable, where it touches, I'm going to declare that s. That's absolutely fine for us to do. Now, because it touches at s, the quadratic has this form: a times x take s squared. Now, we know when x is 1, y is 8. So we can write that in. When x equals 1, y equals 8. Let's put that information in. I'll put 8 where the y is, and I'm going to put 1 where the x is. Okay, so that's our first equation. The second thing we're going to do is use this point. We've got when x is 0, y is 18. So let's put that in. We're going to put 18 where the y is, and we're going to put 0 where the x is. So that's going to just leave us with minus s squared. And so this is, now minus s squared is just s squared, isn't it? So we have as squared is equal to 18. All right. And so what another way that we can understand this as well, I might just leave it like that for now, actually. So we've got two simultaneous equations, right? And we need to synthesize these somehow. We need to bring them together. The very first thing we might do, I'm just trying to look what's the most, there's heaps of ways we can do that. And I'm just looking at these going, what's going to be the fastest way? I can't really see an obviously clear way of doing it. So what we will do is expand this term. We've got 1 take s squared. So I'm going to use the perfect square rule there. 1 take s squared, that's going to become 1 take away 2s plus s squared. Okay, so we've done a bit of expansion already. That's the perfect square rule. I've still got that a out the front, and it's equal to 8 over here, isn't it? All right, now if we distribute this through, we're going to have, even then, what we might do, because we need to bring these together, right? I'm going to divide this one. If we go over to this equation, I'm going to divide both sides by s squared. That's going to give me 18 on top of s squared is equal to a. All right. And so now, if I write this equation out in terms of a, I'm going to perform the substitution. I'm going to move 18 on s squared where the a is. What have we left with? We've got 8 equals 18 on top of s squared multiplied by 1, take away 2s plus s squared. Now the beauty of this is that here we had two variables. We had a and s. Here we've only got one variable. S is the only variable, and so we can go ahead and solve this one. First, let's expand it. So I'm going to distribute this in here. We're going to have 18 on s squared, take away, we will have 2 times 18 is 36 on top of s, and then we will have plus 18. All right, so that's what that one's becoming. If we you can see we've got the variable as the denominator. That's not very helpful for us. So we can multiply both sides by s squared. And what that, I mean, we could have done it up here, it doesn't really matter. We're going to multiply both sides by s squared to get rid of the denominator. So here we'll have 8s squared. Over here we're going to have, when we distribute the s squared, we'll have 18. We'll have 36s, because we have s squared at the top and s at the bottom. And we'll have plus 18s squared. Okay, now we can collect them. And we're going to collect them by subtracting 8s squared from both sides. And you'll see we'll have over here 0, and over this side we'll have 36s plus 10s squared. All right, we're almost there. I'm just going to write this out as a quadratic. We have 10s squared, take 36s plus 18. We need to try and solve this, and it's equal to 0. We need to try and solve this quadratic. One very obvious thing we can go through is divide both sides by 2. So we could have 5s squared, take 18s plus, and that'd be 9, equal to 0. All right, so we can just start to break it down to isolate the terms to make it a bit easier to solve. Now, remember one process we can do when we're asked to solve a quadratic trinomial like this. First, let's see if it's going to have rational roots. So just in my polynomial solver, it's a quadratic. We've got 5, minus 18, and positive 9. And it does have rational roots, so I know that because they're whole numbers. So let's talk about how we can get to those. Another strategy. What we can do is we can multiply this number by this one. Okay, so 5 times 9 is 45. So that means I'm going to rewrite this quadratic like this. We've got s squared, take away 18s, plus 45. And now just like we did when we're factorizing a monic quadratic trinomial, we're saying we need two numbers that multiply together to be 45, and when you add them together, you get minus 18. So we have the product is 45, and the sum is minus 18. So it's going to be minus 15 times minus 3, right? Minus 15 times minus 3 gives us positive 45, and when you add those together, you get negative 18. So that means we can write it like this. We've got s take 15, and we have s take away 3. And now remember we multiplied through by 5, so that means we need to divide both of these numbers by 5. So I'm going to have s take 15 on 5, and I'll have s take away 3 on top of 5. Now 15 does divide by 5, right? 15 divided by 5 is positive 3. Here, 3 does not divide by 5 and give us a whole number. So that means we need to move that 5 up here, don't we? We have 5 lots of s, take away 3. And then we're just applying the null factor law. Either s take 3 is 0, or 5s take 3 is 0. This is going to give us s is 3, or 5s is 3. This gives us s is 3 on top of 5. I'll just try and make a clear distinction between my s's and 5's. So we have two solutions. Either that x coordinate of the vertex is 3, or it's 3 on 5. Both of those circumstances will satisfy these conditions. Now that's quite a tricky problem, right? That is quite a tricky problem. So I'll just recap how did we go through that? What's the whole thing that's going on here? There's a couple of steps. All we're doing is identifying it touches. So that means the quadratic's going to have this form, right? So we establish that it has that form. We've got two variables. We use both pieces of information. The first is when x is 1, y is 8. So we've used that, and we get this equation, and we use the y-intercept. When x is 0, y is 18. We use that, we get this equation. And then what we need to do, we've got two variables, we need to bring them together somehow. So if you remember, I rearranged this one. I made a is 18 on s squared, and then I substituted it in here, and then I reduced that down to one variable. And then it's just a matter of performing the algebra on this equation, expanding it, manipulating it, making it into a nice easy quadratic, factorizing the quadratic to obtain the solutions. Quite a tricky problem there for question 13. Okay, let's move on to question 14. We have a doorway is to be parabolic in shape and 2 meters high. At a height of 1 meter above the ground level, the width of the opening is 1.6 meters. How wide is the door at floor level? So we're going to try and model a quadratic with these conditions, right? There's a couple of ways we can do it. Let's start with this. Let's say that's one of the roots, okay? It's got this kind of shape, right? Now, we know it has a height of 2 meters. So I'm going to set the ground level here at the line y equals 1. Let's call that the ground level. Doesn't have to be done this way, but here's one way of doing it. Ground level, y is minus 1. So then the maximum height is y is 1. All right, remember the height of the tunnel is 2 meters. So if we're 1 meter below and 1 meter above. Now, the reason I've done that is because then we can set these roots. We know the distance between these 2 points is 1.6 meters. So if this root is 0, well, this root is going to be 1.6. And we can start to set up the quadratic in this manner. We also know this axis of symmetry occurs exactly halfway between the points, so the roots. So halfway between them, the x value is 0.8, the y value is +1. So the equation of this quadratic then is going to be, now we could set it up using the vertex formula, or we could set it up using the roots. Either's going to be fine. Let's use the roots. So the equation of a quadratic is y is a times x take p times x take q, right? And our roots are 0, so our first one is going to be x, and our second one is x take away 1.6. Now we don't know this dilation factor, but we do know when x is 0.8, the y value is 1. So we need to use that to determine the dilation factor. We'll put 1 where the y is. We're going to put 0.8 where the x is. And we'll just process this a little bit. 0.8 out the front. Now 0.8 take 1.6 is going to be minus 0.8. And 0.8 times 0.8 is going to be 0.64. Still got the negative on it. So we've got this a value is 1 on top of minus 0.64. Might be able to simplify that using our calculator. We can check in a moment. So that means the equation of this quadratic, okay, is y is minus 1 on 0.64 multiplied by x times x take 1.6. And even then you can distribute that x if we want to. So it's x squared take 1.6x. So I've just multiplied the x through there. So this is the equation of the quadratic, right? Now what we want to know is how wide is the tunnel at ground level? That is, how far apart are these points? So I'm just going to use my calculator. So let's go in and graph it, right? The equation of the quadratic is minus 1 on top of 0.64. And we've got x squared, in brackets, x squared take 1.6x. That's the equation of the quadratic we're dealing with. Change our v window a little bit. We don't need to go up very high because our maximum y value, and we don't need to go very wide either. We'll just go from minus 1 to 3. Okay, we can start to see it there. The other thing I'm going to do is graph the line y equals minus 1. So now that red line is the ground level. And we're saying how far apart is the tunnel at ground level? Well, I can just g-solve these points of intersection, right? So the one to the left, we've got x is minus 0.331. And the one to the right, we've got x is 1.931. And so we're saying how far apart are they? Well, 1.931 take away 0.33, take away negative 0.331. All right, and that's going to leave us with our answer. 1.931, take away negative 0.331. We've got 2.262. That's how far apart in meters the quadratic, the roots of the quadratic are. Okay, so if we want to know how far is it from the left-hand point to the right-hand point, we do the right one, take away the left one. That's going to leave us with that distance between them. Okay, so another tricky problem there. Again, this is one way of doing it. We could use the vertex form as well. Both are going to generate the same solution. All right, it's just about using a quadratic model to find the answers. Okay, move on to the next one. Next, we have question 15, which says, find x if we have this cubic here. So we have question 15a. We've got x take away 3 multiplied by x squared plus 2x take 2 being equal to 0. So we need to solve this cubic. I know it's a cubic because we have a linear multiplied by a quadratic, so the leading term would have a power of 3. And we're just going to apply the null factor law. Either x take 3 is 0 or x squared plus 2x take 2 is 0. Here we have the solution x is 3. Over here, we we'll have to factorize this. Now remember, one way to check if your solution has rational roots and can be factorized is using the discriminant. So if we do the discriminant here, we're going to have 4 take away 4 times 1 times minus 2. This is going to become 4 plus 8, which is positive 12. The discriminant is 12. Now, you can only factorize it if the discriminant is a square number. Remember, the square numbers being 1, 4, 9, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc., etc. This is not a square number, which means there's no rational solutions to this. So you can go ahead and use quadratic formula, or we can use our calculator. So it's a polynomial. This component is the quadratic, and we have an a value of 1, b 2, c minus 2. And you can see these roots, minus 1 plus root 3, minus 1 take root 3. So we've got x is 3, minus 1 plus or minus root 3. They're our solutions. 3 roots for the polynomial. Okay, so that was 15a. Let's move on then to question 16. Here we've got some intersection of the following graphs. So find the intersection of a quadratic with a line. So I'm going to tear off here. The first thing we can do, right, is just graph them. You can just graph them and G-solve it. Like if I go into graph mode and I've got x squared plus 2x plus 1, that's the quadratic, and I've got 2x plus 2, that's the equation of the line. Can't see it. Whenever you can't see it, you need to change your V window. I'm just going to set it to standard. And I can see there 2 points of intersection, G-solve intersection. The coordinates are x is minus 1, y is 0, and x is 1, y is 4. Now to do an algebraic process, what we have is we have x squared plus 2x plus 1. So this is question 16. And the other equation is 2x plus 2. Now, these are going to meet, these equations are going to meet when they equal each other. So that means they're going to meet when x squared plus 2x plus 1 equals 2x plus 2. That's when they're going to meet. And so we just need to solve this. Now, one thing we'll do is collect the quadratic on one side and try factorize it. So I'm going to subtract 2x from both sides. So x squared plus 2x, take away 2x. So I'll take 2x to move it off here, and I'm going to take away 2. I'm moving all of that onto the left-hand side. Okay, over here, let's collect it. 2x take away 2x, that will cancel, and 1 take away 2, that's going to be minus 1. Now, whenever we have a quadratic like this, because we don't have a b term, we just have x squared take 1 equals 0, we can move it over and then square root both sides. We have x is plus or minus 1. The other thing, like whenever you see something like this, another way to think about it is that's difference of 2 squares, isn't it? It's x take 1 times x plus 1. We have a squared take b squared, a take b times a plus b. That's a pattern that's going to keep popping up. You've got to keep your eye out for that. And of course, using the null factor law here, you get the same solutions. So we have the x value. They meet when x is 1 and x is minus 1. Then we need the corresponding y value. Now, because they meet at the same point, both of these are going to have the same y value. It's much easier to put it into this one. We're going to go when x is positive 1, y is going to be 2 times 1 plus 2. That's 2 plus 2. The y value is 4. And when x is minus 1, y is 2 times minus 1 plus 2, 0. So the points of intersection, x is 1 and y is 4, and x is minus 1, y is 0. X is 1, y is 4, x is minus 1, y is 0. Okay, next one's definitely a little bit more tricky. We have 3x squared plus 4x plus 7. So this is question 16c. And we have x squared, take 4x plus 1. Now just check in our calculator, see if they have rational solutions. So we have, 3x squared plus 4x plus 7, and x squared take 4x plus 1. Okay, 3x squared plus 4x plus 7, x squared take 4x plus 1. Good, happy with that. And I'm just going to crank my y max right up. So I can see one point of intersection there and another point of intersection there. Let's just G-solve them quickly. All right, so the first one's a nice solution and the second one's a nice solution as well. So that means we can find these via factorization. Remember, the first thing to do is make them equal to one another, and then I'm just going to move this whole quadratic over to this side by subtracting every term. So if I have 3x squared take away x squared, we'll be left with 2x squared. We're going to have 4x take away minus 4x. 4x take away minus 4x becomes 4x plus 4x. So that becomes plus 8x. And we have 7 take away 1, that'll be plus 6. Now, here you might be going, oh, that's a non-monic quadratic trinomial, tricky to solve. Well, one thing we can do here is 2 is a common factor. In fact, we can divide both sides by 2, and then this is the equation that results. And this is a very easy equation to factorize, right? Two numbers that multiply together to give you positive 3. And when you add them together, you get positive 4. So x plus 1 and x plus 3. Apply the null factor law. So we've got the two x values, and then to find the corresponding y value, we take that x value and plug it in here. So I'll just do it for the first one. When x is minus 1, y is minus 1 squared. Take 4 times minus 1 plus 1. So that's going to be 1 plus 4 plus 1, 6. All right. And so we have when x is minus 1, y is 6. All right, so that's the first coordinate. Then we can go when x is minus 3, y is, we can plug it into this one. We can plug it into either. Both will generate the same solution, but we get the y value is 22. Very good. Let's move on then to question 17. All right, we're back for question 17, and we're solving some simultaneous equations. So we have xy take 3 equals 3y plus 1. That's our first equation. And our second equation is y take x equals 1. So when we have a simultaneous equation, what we've got is we've got two variables in this equation and two variables in this equation. And we're trying to, we're going to synthesize the variables together somehow to find a solution that matches both of them. So if we have a look at this one, we can really easily arrange this to get y by itself, right? We can add x to both sides, and so I have x plus 1. And now that I've got that, I'm going to substitute that into this equation everywhere there's a y, and that's going to, what that's going to do, so if I do that now, I'm putting x plus 1 where there's a y. What it's done, if we look carefully, is it's reduced all of this down to one variable. We don't have two variables anymore, we've just got one variable, which is x, and we're going to solve through for x. Multiply both sides by, expand here, we've got x squared plus x, take away 3. Over here we'll have 3x plus 3 plus 1, and we're just going to collect it all onto one side. 3x plus 4 over here. We'll subtract 3x and subtract 4 from both sides. So subtract 3x and subtract 4. So we're going to move that over. And we've got a 0 on the right hand side. And so that means we're going to be left with x squared, take away 2x, take away 7. Now, this is going to have irrational roots. I can see from looking at it, b squared, take away 4ac, the discriminant is positive 32. It's not a square number, which means it is going to have irrational roots. So let's go through and get those roots using the quadratic formula then. I'll just pause and turn the lights on quickly. Actually, maybe I'll just leave them off. It doesn't look too bad without the lights. Just make sure I don't have my flashlight on. Yep, we're good. So we're using quadratic formula here to solve this. So we've got minus b plus or minus the square root of b squared, take away 4ac, all on top of 2a. Now, this becomes positive 2. This becomes 4 plus 28. So that's where I got 32 from. And this is all on top of 2. Now, square root of 32 is the same as 2 times the square root of 16, right? So we've got 2 plus or minus here, it's square root of 16 times 2, which is square root of 16 times square root of 2, which is 4 root 2. Okay, square root of 32 can simplify to 4 root 2. So we have 2 plus 4 root 2 on top of 2, and 2 take 4 root 2 on top of 2. And divide both by 2, we're going to have 1 plus 2 root 2, and 1 take 2 root 2. So we have our two solutions, or our values of x, that satisfy this simultaneous equation. Next, we need the corresponding y values. So if x is 1 plus 2 root 2, then y is equal to x plus 1. So it's going to be 2 plus 2 root 2. And if x is 1 take 2 root 2, then y is going to be, well, it's x plus 1. So it's that plus 1, 2 take away 2 root 2. So we have two solutions to this set of simultaneous equations. Both of those values satisfy it. So that's quite a tricky one. Let's move on to 17c. We have x squared plus y squared is equal to 16. And we have, so this is 17c, and we have 2y plus x equals 3. All right, let's start by getting, let's get x by itself this time. So I can rearrange here. We're going to have x equals 3 take away 2y. All right, I can rearrange to get x by itself. Now I'm going to substitute that into here, all right, where the x is. So we have 3 take away 2y squared plus y squared is equal to 16. Now we're going to expand this using the perfect square rule. Okay, perfect square rule pops up again. You need to know how to expand it. That's going to be, so it's a take b squared, right? Is a squared take 2ab plus b squared. And a corresponds with 3, b corresponds with 2y. So it's going to become 3 squared, take away 2 times 3 times 2y plus 2y squared. Okay, so that whole thing is going to expand to this. Then we have this plus y squared hanging out here and equals to 16. All right, let's collect. We've got 9. Take away 2 times 3 is 6, times 2 is 12. 9 take 12y plus 4y squared plus y squared. And I'm going to move the 16 over to this side. Take away 16 is equal to 0. And we'll write this as a quadratic. We've got y squared plus y squared. That's 5 lots of y squared. That's our leading term. Take away 12y. And then we have 9 take away 16. If we have positive 9 take away 16, we're left with minus 7. All right, so we have a quadratic trinomial again. We can use our calculator to solve it. We can use our calculator to check if it's going to have rational roots and so forth. We have 5 minus 12 and minus 7. It's got irrational roots again. So the values of y that satisfy this simultaneous equation are irrational. So I'm just going to go through and get those quickly. We have y is 6 plus root 71 on 5, or 6 take root 71 on 5. Now, in the circumstance that y is 6 plus root 71 on 5, then the x value is going to be 3 take away 2 lots of it. Okay, I'm getting that from here. X is equal to 3 take away 2y, 3 take away 2 lots of y. And similarly, the same for this one over here. 3 take away 2 lots of 6 take root 71 on 5. So they're pretty nasty simultaneous equations because they didn't pop out with any nice solutions. All right, let's move on to question 18 then. In 18, we have used technology to find the zeros of these equations. So the first equation is 2x to the 3, take 9x squared plus 7x plus 6 equals to 0. So there's two strategies. I'm going to employ both in different questions. So the first one is to go into equation solver. It's a polynomial, it's a cubic. Everything's on the left-hand side. We know it's a cubic because the leading power is 3. And then we just input the coefficients, right? 2 minus 9, 7, 6, solve. So the zeros are the roots, the x-intercepts are 3, 2, and minus 0.5. So sorry, this is question 18. X is 3, 2, and minus 0.5. All right, let's move on to the next one. We have another cubic. So for C, it is 3x to the 3, take 7x squared, take 28x plus 10. Again, everything's on the left-hand side. All right, so that's what we want to make sure we do. We can do that in graph mode. We've got 3x to the 3, take 7x squared, plus take 28x, and plus 10. All you do, G solve the roots, and these are going to be the solutions. Minus 2.32, 0.33, and 4.31. And another solution, x to the 4 take x squared equals 2. What we can do here is we can graph both of these. So I'm going to graph the left-hand side, x to the 4 take x squared, and I'm going to graph the right-hand side, which is 2, and then you can just G solve points of intersection. And we've got G solve intersection. We've got x is 1.414, that's the square root of 2, and over here, negative 1.414 and positive 1.414. So that's how we can use technology. We can go into equation solver, everything on the left-hand side. We can graph with everything on the left-hand side and G solve the roots, or we can make the left-hand side, graph the left-hand side, graph the right-hand side, and G solve the points of intersection. 3 strategies we've explored there. Very good, let's move on to question 19 then. I won't tear off this page, we've got plenty of room still left. All of question 19, we write the following in the form x to the power of n. So we have the square root of x, that's x to the power of a half. We have 1 on x, that's x to the power of minus 1. We have 1, that is x to the power of 0. Any number to the power of 0 is 1. We have the cubed root of x squared. This is the same as x squared to the power of a third. All right, cubed root means you make it to the power of a third, and we multiply these two powers together. That's going to be x to the power of 2/3. We have the square root of x on top of x squared. This is going to be x to the half on top of x squared. All right, so both as a number. And then it's the top power take away the bottom power, right? X to the half take away 2, and half take away 2 is minus 3 on 2. So just simplifying that using our index laws that we're familiar with. Last one, so that was E, we're on to F. F is x squared multiplied by the cubed root of x squared. All right, now we know this one, the cubed root of x squared, we know that that simplifies to 2/3. We've done that one already. All right, so I'm just going to straight away simplify that one to x to the power of 2 on 3. Now, these have the same base, so we're going to add those powers together. So it becomes x to the power of 2 plus 2/3, and 2 plus 2/3 is going to be, that's 6 on 3, it's going to be 8 on 3. Very good. So that's question 19. All right, let's move on to question 20. Write as a sum or difference of terms. So if we have x plus 1 on x squared, all it means is we're going to split that denominator. We have x on x squared plus 1 on x squared. Okay, so we've split it there like that. And these can be simplified, right? We have x at the top and x squared at the bottom. That would simplify to 1 on top of x. And over here, that's just going to stay as it is. We've separated it into 2 terms. So that's question 20A. Let's go to 20B, where we have x take 2 on x cubed. Okay, this is going to be x on x cubed, take away 2 on x cubed. All right, x on x cubed is 1 on x squared. All right, using index laws. Maybe I'll break that part down for you actually. So if we have x on x cubed, right, what this means, it's the same as x on top of x times x times x. Now we have x at the top and x at the bottom, so one of them can cancel. We're left with one lot of x, 1 at the top and x squared at the bottom. Okay, so that's how that simplifies down here, or you can use index laws. So that's B. Let's have a go at C here, if I can squeeze it in. We have 2x squared plus x plus 1, all on top of the square root of x. So we'll split this to be 2x squared on top of the square root of x, plus x on top of the square root of x, plus 1 on top of the square root of x. Okay, so the denominator belongs to every term, right? And so then using index laws, we've got 2x squared on x to the half, we've got x to the 1 on x to the half, and we've got here 1 on the square root of x. That term we won't simplify. I mean, we could express it as a negative power, but here we have the same base at the top and the bottom. So we can do the top power, take away the bottom power. Now 2 take away a half is 1.5, or 3 on 2. Here, 1 take away a half is half. And then here we've just got the 1 on root x. So we can simplify or split it up so that it looks like that. Okay, last one for question 20D we've got. And we've got x squared, take 3x plus 10 on top of x root x. Okay, split it up. So x squared on x root x, take away 3x on x root x, plus 10 on x root x. All right, so I'm looking at this term. This term's got x at the top, x at the bottom, so that can cancel straight away. Here we've got x squared on top of x root x. Now, one thing you can do is go, oh, that's x times x on top of x times root x. So you can cancel one of those straight away if you want to. You can start thinking of it like that. Also, remember, x root x is the same as x to the 1 times x to the half, and you can collect those. 1 plus a half is 3 on 2. So whenever you see this, x root x, it means the same as x to the 3 on 2. Got to look out for that. And so here we're left with x on top of square root of x, so that's x to the 1 on top of x to the half. We just did this one before. Top power take bottom power, that becomes x to the half at the top. And of course, x to the half you could express as the square root of x. Anyway, we'll leave that one. All right, let's move on to question 21 then. We've got all of question 21 to do. So these look nice. I'll do 21a here. We've got x plus 3 to the power of minus 3 equals 8. So firstly, x plus 3 to the minus 3, this is what it means. It means 1 on top of x plus 3 cubed equals 8. All right. Now, one thing we can do is we can expand it and try and solve it like that. But I think what we're going to do here is we're going to get rid of this cube. All right. We're going to get rid of this cube by performing the cube root of both sides. So let's just do that straight away. Remember, we can do anything we want as long as we do it to both sides. And so I'm going to cube root this side and I'm going to cube root this side. Now the reason I'm cube rooting it is because how do you get rid of the power of a 3? You cube root it. It's just like how do you get rid of, if you have x squared equals 16, how do you get rid of the squared? You square root. Okay, here we've got cubed. How do we get rid of the cube? We cube root. So I'm applying the cube root to both sides, right? And so that means at the top here, I'm going to have the cubed root of 1. And at the bottom, I've got the cubed root of x plus 3 cubed. The cube root and the cube cancel. So at the bottom, we just have x plus 3. Over here, we're going to have the cubed root of 8. Now, the cubed root of 8 is 2, isn't it? 2 times 2 times 2 is 8. And so here's what we have. The cube root of 1 is 1. So we have 1 on top of x plus 3 equals 2. We're now solving this equation. We'll cross multiply or multiply both sides by x plus 3. This becomes 2x plus 6. Subtract 6 from both sides. Minus 5 is 2x. Divide both sides by 2. Minus 5 on 2 is x. Okay, so the tricky part there was to cube root both sides. We're going to see that pop up in the next few as well. So a skill that we get to cement here if that confused you a little bit. So again, this time we've got x plus 2 to the power of minus a third equals 2. All right, so minus a third, all right, that means cube root, and the minus means it's at the bottom of the fraction as well. So you can just put it to the power of negative 3 here if you want to. Like if we're trying to break this down, we can do it at this step, or we can simplify using the surd and index rules as well. So it doesn't really matter. Let's do it a little bit different this time. Let's just put both sides to the power of minus 3. Now the reason we would do something like that is because if I have minus a third times minus 3, minus a third times minus 3, that's going to be positive 1. And so I've reduced the left-hand side to x plus 2 in one single step, right? And over here, we have 2 to the power of minus 3. That's the same as 1 on top of 2 to the 3. and 1 on top of 2 to the 3 is 1 on 8, right? So we have x plus 2 is equal to 1 on 8. So we'll subtract 2 from both sides. 1 on 8, take away 2. Now, in order to perform an operation like this manually, they need to have the same denominator. So we have 1 on 8, take away 16 on 8. 16 divided by 8 is 2. So we're just expressing that. And 1 take away 16 would be minus 15 on top of 8. So this is the solution to this equation. All right, all we had to do was put both sides to the power of minus 3 in order to get rid of it. All right, in order to get rid of that power so we can get the x term by itself. All right, and then on to C. On C, we've got x, and this is going to be a tricky one. Now, what we've got on the left-hand side, we've got x take 2 to the minus half. And on the right-hand side, we have the square root of x take 2. So I'm going to get you to think of it like this, like x take 2 to the minus half, that's the same as 1 on top of the square root of x take 2. All right, the negative makes it at the bottom, the half makes it square root, right? Now, one thing we can do here is just square both sides. Okay, we're trying to solve the equation. We can do anything we want as long as we do it to both sides. So what I end up with on this side is 1 squared, which is just 1, so it has no impact. The squared gets rid of the square root at the denominator here, and the same with the term on this side. Now, if we're trying to solve this, we're going to multiply both sides by that denominator. So we'd have 1 equals x take 2 squared. Now, you can expand it if you want to, but there's an easier way. Here we've got x inside the brackets. We've only got one variable. We can square root both sides. So here we'll have plus or minus 1. Here we would have x take 2. And then to get x by itself, we'll have x is, so moving the 2 over, 2 plus or minus 1. We have 2 plus 1 or 2 take 1. We have 3 or 1. Those are the solutions that satisfy this equation. So just here, what did I do? I moved the 2 over. We added 2 to both sides. And so we have x is equal to 2 plus or minus 1. And I've just stated it with the variable on the left-hand side. So often my preference is just to keep the variable x on the left-hand side. So that was question 21. Let's move on to question 22. Now, in question 22, we're equating bases. So we've got 4 to the power of x equals 8. Now it says use a common base. So we need to make them have the same base. Now here I know 4 to the 1 is 4, 4 to the 2 is 16. So these don't have the same base at the moment, but I can express this as 2 to the power of 2x, and I can express this as 2 to the power of 3, right? So 2 to the power of 2x and 2 to the power of 3. Now, because they have the same base, the base is the same, therefore the power has to be the same as well. And so we have 2x is 3, and so the solution here is x is 3 on 2. So this is question 22a. Let's go on to 22b. We have 9 to the x is equal to 3 to the 1 take x. To make them have the same base, I'm going to express 9 as 3 to the power of 2. Right, 3 to the power of 2 to the power of x is 3 to the power of 2x. Now, same base, so therefore we can equate the powers. 2x is equal to 1 take away x. I'm going to plus x to both sides, and then I'm going to divide both sides by 3. So the solution here is x is 1/3. All right, plus x to both sides moves that over, so we get the x's on one side, the numbers on the other, and then dividing through by 3. All right, in C, we've got 3 to the 2x plus 1 equals 1/3. Now, 1/3 is just 3 to the minus 1. All right, so at the bottom there, the power is 1. We can take it to the top and make it negative. Same base, so now we can equate the powers. 2x plus 1 is minus 1. We want to get x by itself, so we'll subtract 1 from both sides, divide both sides by 2. There's our solution. Okay, on to D. We have 5 to the power of 2 take x equals 1. Now, 1 is 5 to the power of 0. Same base, so now we can equate the powers. 2 take x is 0. I'm going to plus x to both sides. We would have 2 equals x. Our solution is x is 2. So that's question 22. All right, on to question 23. And we're almost finished the first part, aren't we? So on to question 23. We've got use algebra to solve these equations. So we have 3 take 4x is minus 7. So this is 23a. 3 take 4x is minus 7. So we're trying to get x by itself, right? So the first thing I'm going to do is subtract 3 from both sides. All right, if I subtract 3 from both sides, I'm going to have minus 4x is minus 10. What this allows me to do is break it down to get x by itself. Next, we'll divide both sides by minus 4. So we'd have minus 10 on top of minus 4. And 10 minus the negative at the top, negative at the bottom will cancel. And 10 divided by 4 will be 2.25. Or 2.5. That'll be 5 on 2. Let's fix that one up. 2.5. 5 on 2. Very good. So that's A. Next we have C. Let's see if we can squeeze this one in here. We have x plus 4 on top of x take 4 equals 2. Okay, if we're solving this equation, we've got a variable as the denominator. Remember, we can never have that. So we need to multiply both sides by x take 4. Because what it's going to allow us to do is cancel it as the denominator. Multiply both sides by that denominator. 2 times x take 4. And now we're just solving this linear equation. We have x plus 4 equals 2x take away 8. Now we want the x's by themselves and the numbers by themselves. So I'm going to subtract 2x from both sides. That would give us minus x over here. And I'm going to subtract 4 from both sides. We'll have minus x is minus 12, and that gives us positive x is positive 12. All right, dividing both sides by minus 1. Okay, so we cross multiplied, we move that denominator up there, and expanded, and then collected like terms accordingly. So that's 23a and c. Let's move on to 23e. In 23e, we have 2 on top of x plus 2 equals 3. Now the first thing I'm going to do is move that number over there. So we have 2 on top of x plus, if I move the 2 over, so I'm subtracting 2 from both sides, 2 on top of x equals 1. Now with this kind of equation as well, you can look at that and you can observe that the only value of x that satisfies this statement is x is positive 2. 2 divided by 2 is 1. All right, so our solution is going to be x is 2. But what we're going to do here is we have the variable at the bottom. We're going to multiply x by both sides. X at the top, x at the bottom will cancel, and 1 times x is x. So we have x is 2 is the solution for E. Let's move on to G. We have the square root of 2 take x is 3. So we have the square root. We need to square both sides to get rid of the square root. So we have 2 take x is 9. We'll subtract 2 from both sides. And then, that is positive 7. Minus x is 7. And then we'll divide both sides by minus 1. So get, if minus x is positive 7, then positive x is negative 7. So that was G. All right, question 23G. Let's move on to 23J. Pretty similar. We have 4 on top of the square root. Sorry, this is I, not J. This is 23I. 4 on top of the square root of 2x plus 3 is equal to 2. 4 on top of the square root of 2x plus 3 is equal to 2. So we've got the square root there. So really the first thing we're going to need to do is to square both sides to get rid of it. So if I square both sides, I'm going to have 16 at the top and I'm going to have 2x plus 3 at the bottom. The square gets rid of the square root, right? And over here we've got 4. Squaring both sides, maintaining that equality. Now, we've got the variable as the denominator, so the way we get rid of that is multiplying both sides by that denominator. So multiplying both sides by 2x plus 3, it's going to cancel over here. So we'll have 16 is equal to, over here we can expand it, we'll have 8x plus 12. We'll subtract 12 from both sides, so we'll have 4 equals 8x, and then divide both sides by 8. 4 on top of 8 is equal to x, which is the same as half or 0.5. Okay, so that was I, and then we've just got J to do. New page. So for J, we've got, sorry, not J, K. We've just got K to do. We've got 6 on top of x squared take 3 equals 1. Okay, variables in the denominator, so we'll multiply both sides by that denominator, x squared take 3, and over here, x squared take 3. It's going to cancel on this side, so we'll have 6 is equal to x squared take 3. We're going to add 3 to both sides to get x squared by itself. So we have 9 equals x squared. We've only got one variable of x, so we'll square root both sides. So we'll have x is plus or minus 3, positive 3 or negative 3. Very good. Let's move on to question 24. So we've got, what we're doing in question 24 is we're rearranging formula to get a certain variable by itself. So the first one we've got is the area of a circle, and we're asked rearrange it to get r, the variable r for the radius, all by itself. So this is question 24b. So first thing we want to do is divide both sides by pi. And then we've got r squared here. We only want one lot of r, so we're going to square root both sides. So we would have a on the square root of pi is equal to the variable r. All right, on to d. So I might just fence this off here. So we've got 24. Let's go to 24d. We've got c is equal to 4x plus pi x. Now we're asked to isolate the variable x by itself. Now we've got 2 instances of x, which means we absolutely have to factorize that. All right, x is common, so we can pull it out the front. We've got x times 4 plus pi. And then to get x by itself, we would divide both sides by 4 plus pi. Okay, if I divide both sides by 4 plus pi, we have the same thing at the top as we do at the bottom, and it will cancel. All right, so we're left with x is c on top of 4 plus pi. All right, on to f. Now if we go to f, we've got I equals v on r1 plus v on r2. Okay, again, v is common, so we're going to factorize that first. So we have v multiplied by 1 on r1 plus 1 on r2, and then dividing both sides by 1 on r1 plus 1 on r2. We would have I on top of 1 on r1 plus 1 on r2, and we're just left with v by itself over here, okay, dividing both sides by that number. Now this skill looks quite complex, right? But we're just applying the same mathematics you would do when you're solving linear equations, when you're solving algebraic equations. Okay, so that was D and F. Let's go to H here. For H, we've got the square root of r squared. Take x, take 2 squared. And we're asked to solve for x, and it's equal to y. Y equals. Okay, so the first thing we'll do is square both sides. All right, squaring both sides gets rid of the square root. And then I'm going to swap this with the y. I'm going to swap the negative term. So I've got r squared take y squared. I'll take y squared from both sides, and I'll add x plus 2 squared to both sides. All right, so I'm moving that one to the right-hand side, moving the y to the left-hand side. Now we're breaking it down for x, right? So then I'll square root both sides. The square root of the square will cancel, and over here we're left with x plus 2, and then I'll just subtract 2 from both sides. And just to be clear, that square root only belongs to r squared and the y squared, not the negative 2. All right, so fairly tricky these ones, aren't they? What have we done? We square both sides to get rid of the square root. We've swapped the x take 2 squared and the y squared term. We square rooted both sides to get rid of that square, and then we subtracted 2 from both sides to isolate the x by itself. All right, so that was H. Let's move on to J. So for J, we have the square root of x take a, y equals the square root of x take a on top of x plus a. Okay, now this is going to be a tricky one. First, let's square both sides. We're going to have y squared is equal to x take a on top of x plus a. And then we'll multiply both sides by x plus a. All right, to get rid of that denominator, I've moved that up there. Let's expand the left-hand side. We're going to have x times y squared plus a times y squared. All right, now what we'll do, we want the x's on one side and the other values on the other side. So I'm going to move this a to the left-hand side, and I'm going to move this xy squared to the right-hand side. So on the left-hand side, we're going to have ay squared plus a. All right, I'm moving that over here. And on the right-hand side, we're going to have x take xy squared. All right, now here, x is common, so we can factorize x. We're left with 1 take away y squared. Over here, we'll just leave that. I mean, a is common, but we can just leave it. And then we'll divide both sides by 1 take y squared to cancel it over there. So we'd have ay squared plus a on top of 1 take away y squared, and we're left with x all by itself. So that's quite a tricky one, isn't it? All right, so what did we have to do? We squared both sides to get rid of the root. We moved that denominator up, we've expanded, we've got the x's on one side, the other stuff on the other. We've factorized the x, so we've broken it down so there's one x, and then divided both sides by that number. All right, I think we got one more. I'm going to try and squeeze it on here. So this is HIJL. We have 1 on f equals 1 on r take 1 on s. Okay, and this one's not actually too bad. All we'll do here, let's add 1 on s and take 1 on f from both sides first. So we'd have 1 on s on the left-hand side is equal to 1 on r take away 1 on f. All right, so we're subtracting that term from both sides, adding that term from both sides. And then at the moment, we have 1 on top of s. And so this means the same as s to the minus 1, right? Equals 1 on r take 1 on f. And so if we've got s to the minus 1, we want s by itself. Well, we can put both sides to the power of minus 1. And what that will do, minus 1 times minus 1 is positive 1. And so we'll get s is 1 on r take 1 on f, all to the power of minus 1. And this means the same thing as the reciprocal. Like, there are so many ways of expressing this. Because it's to the power of minus 1, you can take it to the bottom of the denominator there. And this could be collected and so forth. We'll give you full marks here. All right. But this skill, like, the point of this one is just to emphasize the algebraic techniques involved in manipulating formulas and so forth. There's a fair bit of that going on in this course as well. All right, so good luck. I'm going to stop there and resume a bit later on. But yeah, that's a good summary of the first 24 questions. All right, guys, welcome back to the video. We're up to constructing functions using geometry here. So we'll get straight into our first question here. We have Amy has a rectangular paddock, is 200 meters by x meters. Find in terms of x only. So firstly, the area of the paddock. So if we have a paddock here, and we've got it's 200 meters this way, and x meters this way. Okay, the area of a rectangle is the length times the width, so the area will be 200x. That's our answer to part A. Part B says the perimeter of the paddock. Well, the perimeter, that's going to be the distance the whole way around it. So we have x and x here, and we have 200 and 200 here. So the perimeter is going to be 200 plus x plus 200 plus x. That's going to be 400 plus 2 lots of x. Okay, we've got the length of fence BD, which would divide the paddock. Okay, the length of this fence. So if we have a look here, we've got a right-angled triangle, right? We've got a right-angled triangle, and let's call it L for the length of the fence. And using Pythagoras' theorem, right, we would have x squared plus 200 squared is equal to L squared. A squared plus B squared is equal to C squared, the hypotenuse there. So we've put those in there. and we're trying to get L by itself, right? We want the length of the paddock by itself. So here we would just square root both sides. X squared plus 200 squared is L. Now, you can evaluate 200 squared, but the square root does not cancel because those are not a product. It's not multiplying, they're separate terms. It's only if they're multiplying that the square root can cancel the squared. So that's as simple as we can get the length. And then we have, lastly, the measure of angle DBC that's given to us. That's this angle in here, which is theta. And so if we take this triangle, right, and we've got here, I'm going to take it out again. We've got 200 and we've got theta and we've got x. And let's label this triangle. This is going to be the hypotenuse. It's the longest side. This would be the adjacent side. It connects theta with the right angle. And this would be the opposite side because it's opposite the angle theta. So if we're looking for a trig ratio that involves A and O, remember the SOHCAHTOA? All right, sine is O on H, cos is A on H, tan is O on A. So in this circumstance, we would use tan because we've got O and A. So we would have tan of theta. So this is part D, question 1, part D for exercise 1B. Tan of theta is O on A. So in this circumstance, tan of theta is 200 on X. And we want theta by itself, so we would perform the inverse tan. All right, so to get theta, tan inverse of tan to the minus 1 of 200 on X will give you the angle theta all by itself. All right, so that's question 1 from exercise 1B. Let's move on to question 2. I'm going to have some room to do it here, I think. So question 2 says, find formula for the perimeter and the area of the following. So we're going to do question 2A and F. So we look at A, we've got this shape here where we've got 2x and we've got x. All right, so for the area then, that's going to be 2x times x. That would be 2x squared. And for the perimeter, it's going to be 2x plus 2x plus x plus x. So 2x, 4x, 5x, 6x. The perimeter is 6 lots of x. Okay, jump down to F. In F, we have this kind of shape. Now there's a bit of ambiguity as to whether the whole length along is x or whether it's just 1/2. I'm going to declare it 1/2. It is a bit ambiguous, but I'm going to declare it 1/2. So we've got that's x, that's 7, and we want the perimeter and the area of this total shape. Okay, so for perimeter, the perimeter is going to be reasonably easy. Like if this length is x, then this length is also x. So we'll do the perimeter first. That's just going to be x plus 7 plus 7. That's going to be 2x plus 14, right? The area is going to be a little bit different. The area of a triangle is half the base times the height. Like it's always half of the square, right? So the base here we can see is x plus x, but the height we need this length here. We need the perpendicular height. We need that value there. And so I'm going to just call that h for now. And so using Pythagoras theorem, if we look at this right angled triangle, this one in particular, we would have x squared plus h squared equals 7 squared. And remember, we want h by itself. So we would write it like this: 7 squared take away x squared. We move the x squared over, and then we would square root both sides. And we can evaluate 7 squared to 49 if you want to. You can leave it like that. Both are absolutely fine. That's the height of this triangle. And so then the area of this triangle is half of the base, which is 2 lots of x, multiplied by the height, which is 7 squared take x squared. The square root of 7 squared take x squared. Now the important point here again is the square root and the squareds don't cancel because they're not multiplying. Out the front here we've got half times 2, so that can cancel, and the area then is x square root of 7 squared take x squared. So that would be our answer for question 2, part F. Very good. So let's move on then to question 3. We have a 24 centimeter length of wire is cut into 2 pieces. One piece is shaped into a square and the other is used to form a circle. Find an expression for the total area of the square and the circle. Okay, so we have 24 centimeters. This length here is x, all right? And then this length here is 24. Take away x, isn't it? Because we've taken x off, so we're just left with 24 take x. All right, now, if we have a straight piece of wire that is x centimeters long and we form it into a square, that means each side is going to be x divided by 4, right? Or a quarter of x. So we have a quarter of x here, plus a quarter of x here, plus a quarter of x here, plus a quarter of x here. All right, so that would be the length of each side. And so that means the area of the square would be x on 4 multiplied by x on 4, right? One side length is x on 4 multiplied by the other side length would give us the area of that square. So the area of the square is x squared on 16. When we multiply fractions, it's just the top times the top and the bottom times the bottom. For the circle, it's going to be a bit more tricky. All right, we're left with that 24 take x, and that 24 take x is going to be the circumference of the circle, right? You're bending that into the circumference of a circle. So the circumference of a circle, the formula for the circumference of a circle is 2 times pi times r, and the circumference of the circle is equal to 24 take x. All right. Now, we're asked to find the area of the circle. We've got the circumference here. The circumference is 24 take x. Now, the area of a circle, the formula for the area of a circle is pi times the radius squared. So that means from here, we're going to need to get r by itself. And you can see all we need to do is divide both sides by 2 pi. Here we've got 2 times pi times r. If we divide both sides by 2 pi, we're going to have r is equal to 24 take x on top of 2 pi. We've got r by itself. And so now then, the area of the circle is pi multiplied by 24 take x on top of 2 pi squared. We've got a formula for the area of the circle. All right, so that's quite a tricky question. Question 3 there, part A. Now on to part B. What is the significance of the values a of 0 and a of 24? So, if we find a of 0, all right, that's when the x value is 0, right? And if x is 0, what it means is the length of the square is 0, and so the square doesn't exist, and all of the wire is used to form a circle. And we can see that here, like if you put 0 into the formula, you're going to have 0 divided by 16, so the area of the square is 0. And then if you put 0 into the circle formula, you're going to have 24. That part goes to 0, so you're left with the area of the circle when we just use all of the wire for the circle. And similarly, so area of 0, the square is not made, no wire is used for the square. And then similarly, when we find a of 24, if we put the number 24 into the square formula, you can see we're going to have 24 squared on 16. We'll have a big number. If we put 24 in here, we're going to have 24 take 24, and this goes to 0. The area of the circle is 0. So when we use the number 24, the circle is not made. And that makes sense in the context of the problem. We have a wire, we're cutting it in half. If x is 0 centimeters long, then it means the circumference of the circle is 24 centimeters long. If x is 24, then it means we haven't left anything over for the area of the circle. So that all makes sense there in exercise 1B, question 3. Let's move on to question 4. Find the area given the perimeter is 20. Okay, so the perimeter of this rectangle is 20. So let's have a look at how we can unpack this one. I'll fence this off here for us. I think we can do this problem right here. So we have the perimeter of this rectangle. This side is x and this side is x, and it all has to add up to 20. So what that means is the total perimeter, like if we call this, we can call this the width or the length, or it doesn't matter, let's call it W, but we basically have 2W plus 2 lots of X is equal to 20, isn't it? 2 lots of X plus 2 lots of the width will be equal to 20 centimeters. That's the total perimeter of this rectangle. We can rearrange this to get W by itself, right? 20 take away 2X, and that's going to give us W, divide both sides by 2, 10 take away X. So W is 10 take X. Now, of course, this is true, because if you have 10 take X plus X, that part's going to be 10, and then you're going to have the same over here, 10 as well, and 10 plus 10 is 20, so the perimeter is 20. Excellent. So the width is 10 take X, and the area, of course, is X times W, so the area is X multiplied by 10 take away X. Length times width, X times 10 take X, that's going to give us the area. We can leave it like that, or you can expand it if you want to. Very good. So that's question A. Let's move on to question C. In C, we have a triangle similar to the one we had before. We've got this length here is X, and we've got the perimeter is 50. All right, so what that means is X plus, let's call this the base of the triangle. So we have 2X plus the base is equal to 50, right? So that means the base of the triangle is equal to 50 take away 2X. Okay, this whole distance along here, 50 take away 2X. Now, we're asked to find the area of the triangle. We need the area function. And the area of a triangle is half the base times the height. So we've got the base, which is 50 take 2X. But we need the perpendicular height. So that means we need the height going up in this direction. We can't just use X, we need the perpendicular height. And so that means we're going to need to break this down a bit in order to determine the height. We're going to need to use that Pythagoras theorem again. Now, if 50 take 2X is the whole way along, what it means is halfway along from here to here is going to be 25 take away X. All right, 25 take X plus 25 take X would give you the 50 take 2X for the whole length. I'm just going to rub that out to clear up my diagram a bit. So 25 take X for each half of the base. And now we can use Pythagoras theorem. We've got the base squared plus the height squared is equal to X squared. So let's write a formula for that down here, and then we can plug it back in here. So we'll have Pythagoras theorem, the base squared, we'll have 25 take X squared plus the height, that's what we're trying to determine, the height squared is equal to the hypotenuse here, X squared. See that I'll draw that right angle triangle out to help you. We've got 25 take X, we've got H, and we've got X. So the relationship is A squared plus B squared equals C squared, right? And so that's all that we've written here. Now we're trying to get H by itself because we need the height for the area of the triangle, right? And so we'll rearrange this. X squared take away 25 take X. Now that squared is outside the bracket. Make sure we keep it the same. So all I've done is subtract that term over to here, and then we will square root both sides. Now that negative won't distribute because of bed mass, right? We would need to perform the square first. So that's the height, can be expressed differently, but we've expressed it there. That's absolutely fine. So that means the height of this triangle is that. And so if the area is half the base times the height, we've got half, here's the base, we're going to put the height in here. It's the square root of X squared take 25 take X squared. Close that square root. So the area of the triangle, half the base times the height, there's our base, there's our height. So again, a fairly tricky one, finding the area of that triangle. Okay, next we're jumping forward to question 5b, and we're finding the perimeter this time. So we have this shape here, which is, we've got a rectangle, and then we've got this semicircle at the top of it, and this length here is 2x. Now we need the perimeter. Given that the area is 400, okay, that's okay. So the total area of this shape, So what we have, let's come up with a couple of different variables here. Firstly, we can declare this one as y, all right? And if that whole length is 2x, it means the radius of this circle is going to be x, right? So if we've got the, let's break it up into the two components. We've got the area of the circle. Now, the area of a circle is pi r squared. Here we have half of a circle, which means the area of this semicircle is going to be half multiplied by pi, and the radius is x, right? We've established the radius of the circle is x. So that's the area of a circle formula. The area of our circle is this one here, all right? Half times pi x squared. Now, we also have the rectangle component here. The area of this rectangle component is going to be 2x multiplied by y. So I'll call that the area of the rectangle is 2xy, which means the total area is going to be the semicircle, which is this one. So half pi x squared plus the rectangle, which is this one, plus 2xy. And that is all equal to, what's the area of this shape? 400. All of that is equal to 400 centimeters squared. Now, we need an expression for the perimeter. So when we think about the perimeter, we're breaking it down into each of its parts. All right, so there we've got, that's a relationship with the area. Now for the perimeter, right, is going to be 2x plus 2 lots of y plus this distance around here, which is half of the circumference of a semicircle. Now remember, so let's call this P for perimeter, 2x plus 2y plus half of a semicircle. So if the circumference of a circle, I'll write it here, the circumference of a circle is 2 pi r, that means a semicircle is going to be half of that, which would be pi r. So the distance around the outside of this component is going to be pi times the radius, which is pi times x. So we have a formula for the perimeter here, but the problem is we have two variables. We've got x and we've got y. And we're told in the question, find p of x. That means reduce it down to that one variable, reduce it down to x. Now this is why they gave us the area is 400, is because we need to rearrange this to get y by itself. Once we've got y by itself, we're going to plug it back into this perimeter equation, and it will be one equation in terms of x. So we had it's a bit challenging to develop that area equation, but let's rearrange it to get y by itself. The first thing we'll do is subtract this term from both sides. So I'm moving it over here. 400 take away half pi x squared. Now we want y by itself, so I'm going to divide both sides by 2x. And then it will cancel, right? So we'll have y is equal to 400 take half pi x squared on top of 2x. And so now we have an expression for y. We're ready to plug it into the perimeter. So the perimeter then is 2x plus 2 lots of y, which is this beautiful component here. 400 take half pi x squared, all on top of 2x. 2x plus 2y, and then plus the semicircle component. All right, so that again, a nice tricky one from question 5b there. That was question 5b. All right, moving on, we've got question 6. So we'll have some room here somewhere to do 6. We'll start at the bottom. We have a paddock has the shape illustrated. The perimeter of this paddock is 400 meters. Okay, part 1 says express y in terms of x. So this one's not too bad. To start with anyway, we have the perimeter, right? The perimeter is going to be 5x plus 5x. Okay, they're both the same. Can you see that? 5x plus 5x. And then we have y plus 6x plus y. So that's the total perimeter, right? I'll write it out. Long form, we have 5x plus 5x plus y plus 6x plus y. And so we'll add all that up. We've got 10x, 16x plus 2y. And 16x plus 2y is equal to the perimeter. And we're told in the question the perimeter is 400 meters. We want y by itself, so we'll subtract 16x from both sides and then divide both sides by 2. Now you can leave it on top of 2 or you can divide both of the terms by 2. This keeps it nice and simple, right? Okay, part B says, hence find the area function. Okay, so if we want to know the area of this, well, the area of the rectangle part is 6x times y, right? So that part's easy. Where we're going to have a bit of difficulty is with the triangle part. Again, we're going to have to do some Pythag there. So if we go to this triangle component, right, what we've got, I'll sketch it out like this. We've got this triangle here where we have 5x, 5x, and the whole thing is 6x, which means each half is 3x, right? Put 3x there, and we'll put a line here. And so we're going to be using that Pythagoras theorem again to get this component by itself. So we have a squared plus the height squared equals c squared. A squared plus b squared is c squared. So I'll call that h for the height of the triangle. We have 3x, so all must be in brackets because the whole thing is squared. 3x squared plus h squared is equal to 5x squared. Rearrange this for h by itself. So we'll have 5x squared take 3x squared. And then we would square root both sides. Now here, here we actually can simplify this one, and I'll show you why. All right, let's square both of them. So we're going to have 25x squared take away 9x squared, and see how the squared applies to both terms using those index laws. And 25x squared take away 9 lots of x squared. That's going to leave you with 16 lots of x squared. So we have h squared is 16 lots of x squared, which means h is the square root of 16x squared. And now, because they are multiplying, we're not adding or subtracting them, we can apply the square root to both terms, right? So the height is 4x. And this is a pretty common triangle, 3, 4, 5 triangle where Pythagoras theorem works. So that means the height of this triangle is 4x. We've got all of the components we need to find the height, to find the area. So we said before the area of this function is, we're going to have the rectangle plus triangle. So you can write it, make these kind of arguments if you want to. The area of the rectangle is 6x times y, and we already found y in terms of x. We found y was 200 take away x. So that means the area of the rectangle is 6x multiplied by 200 take 8x. Okay, so that's the rectangle part. Next we need the triangle part. So I might go to a separate line. So that's the rectangle. And then for the triangle, so the area of one triangle, right, is going to be 3x multiplied by h. So the area of one triangle is going to be 3x times the height, which is 4x. But we have two triangles, don't we? We've got the one on the right and we've got the one on the left. So we have 2 times 3x times 4x for the area of the triangle. So that means the total area function then, we'll write it out a bit neater, and we can actually collect a few like terms here and simplify it. So let's go ahead and do that. Look at this part. We've got 6x times 200. That's going to give us 1200x. Here we have 6x times minus 8x. That's going to give us minus 48x squared. And then here we have 2 times 3x, which is 6x, times 4x is going to be plus 24x squared. And so these are like terms. We can collect them. And so we're left with the area 1200x take 24x squared. Okay. Part C, explain why 0 is less than x, which is less than 25. All right, so if we set x as 0, if x is 0, it means, if the value of x is 0, it means if x is 0, this length is 0, and so you can think the paddock's going to have this kind of shape. It's going to be really, really long. because if x is 0, then it means y is going to be really large. In fact, y is going to be 200. And what you would have is you would have these two fences that are parallel to each other. And in the same position, they're not far apart at all. Whereas if x is 25, down the bottom here, you would have 6 times 25. 6 times 25. And so that's 150. And then you're going to have this y value would be 200 take away 8x, which would be 200 take away 8 times 25, which is 100 and that's 200. So the y value would be 0. And so in that circumstance, you've got this sort of, you're just going to have a triangle because the y value is going to be 0. And so if the y value is 0, it means the height of the rectangle here is 0. Okay, so let's explain why. All right, what's the best way to explain it? So x cannot have a negative dimension. X has to be at least 0 or positive because a magnitude of a side cannot be negative. And why can't it go above 25? If it goes above 25, then the perimeter exceeds 400. So these are the constraints for which the value of x must lie within. So just articulating that in some way, x must be positive as a length cannot be negative. And x must be less than 25 in order, so let's fence this off here. X must be less than 25 in order to maintain 400 meter perimeter. Okay, if the x value goes above 25, then we've exceeded the constraint of the 400 meter perimeter, which was imposed by the problem. Okay, very good. That was question 6. Now on to question 7. We have these cones, and we're going to be using a technique called similar triangles. Now firstly, we do need to know that the volume of a cone is 1/3 of pi times the radius squared multiplied by h. Okay, so this is the volume formula for a cone. Now in our first example, so this is question 7a of exercise 1b, we have a cone, and I'll just sketch it out roughly, two-dimensional sketch of it, where we have x here. All right, the water level has a radius of x, and at the top of the cone it has a diameter of 6, which means the radius is 3. Okay, halfway across would be 3. And we know the cone as well has a height of 8. So I'm going to abstract both of these triangles for you. One of them is a triangle with a base of 3 and a height of 8. And the other one's a bit smaller. It has a base of x and a height of, we don't know, we're just going to call it h. Now these are similar triangles. They're similar because the cone maintains the same angle throughout its shape. So if we have a look here, what that means, because they're similar, is we can construct a relationship between these sides. And it can be of any of these forms. But well, let's say, for instance, h divided by 8. h corresponds with 8. So h divided by 8, right, is going to equal x divided by 3, because x corresponds with 3. So h divided by 8 is equal to x divided by 3, because they are corresponding. Now from here we can multiply both sides by 8 to get h by itself. And so we've got the height of the cone in terms of x. We've got the height of the water level, more like it, in terms of x. So that means the volume of water then, so if the volume is 1/3 pi r squared h, the volume is going to be 1/3 pi x squared multiplied by the height, which is 8x on top of 3. Now that can be simplified, like we can multiply the x's together and move the 8 out the front and so forth, but it's absolutely fine to leave it like that. We've found an appropriate volume formula. Excellent. Let's move on to 7c. Now in 7c we have a triangular based prism. And again, we're going to be using similar triangles. So at the moment we have this triangle, which has a height of 50. All right, so the height is 50 and the base is 40. and we're going to be comparing that with a triangle that has a height of x, and we don't know what the base of this triangle is. We'll just call it B for base. So I'm looking at this example. You can see the big triangle, height of 50, width of 40, and the little triangle, height of x, don't know the size of its base. So we want, for the volume, all right, for the volume of a rectangular prism, we're just going to calculate the volume, the area of this shape, and then multiply it by the depth. Okay, the area of this shape multiplied by the depth, cross-sectional area times depth. Excuse me for one moment. Okay, so we were just establishing these triangles are in a similar ratio, right? And so that means we want the base so that we can develop a formula for the area of this triangle. All right, and so for the base, we're going to have the base divided by 40. The base corresponds with 40, right? The base divided by 40 is equal to x divided by 50. All right, the base corresponds with 40, x corresponds with 50. And we must have x at the top because we're doing the base at the top of the fraction as well. Now from here we can multiply both sides by 40 to get 40x on 50. All right, and that can be simplified as well to just 4 on 5x, dividing both sides, the top and the bottom by 10, by a factor of 10. So we have the base in terms of x. Now that means the area of this triangle, right? Remember, the area of a triangle is half the base times the height. So in this circumstance, it's going to be half of the base, all right, multiplied by the height, and the height of the triangle is x. So this comes out to be half times 4 and 5. Whenever we're multiplying fractions, it's the top times the top and the bottom times the bottom. So we have 4 on 10, and we have x squared. And 4 on 10 can simplify to be 2 on 5 as well. So we have 2 on 5x squared is the area of the triangle. Now we're asked to find the volume of water. So volume is this is what we call a uniform, it has a uniform cross area, so it has that shape it has that area throughout the whole shape. And so to determine the volume, it's just the cross-sectional area multiplied by the depth. Now the depth is 2 meters, but notice how our expression for x is in centimeters. We must have the same unit. So let's go ahead and convert that to centimeters. 2 meters is 200 centimeters. And so the volume is the area multiplied by the depth. And so that's going to be the area multiplied by 200. So 400 on 5x squared. And so what's that? 80x squared will be the volume of water in question 7C. All right, on to question 8. Okay, looks like a good one. I like these kind of problems. So in question 8, I'll just bring it up here so we can have a look at it. We have find the area function for the shaded rectangle. So we have the equation of a line, right? Okay, here's the line here. And the equation of this line, it has a y-intercept of 6 and an x-intercept of 8. So, let's find the equation of that line first. All right, so the equation of a line is y equals mx plus c. Now, we know the y-intercept. We can see that it's 6. We don't know the slope, but remember, slope is, we can do y2 take y1 on x2 take x1. So we've got 2 coordinates there, right? We've got x is 0, y is 6, and we've got x is 8, y is 0. So we can use that, or we can just treat it as the change in y divided by the change in x. So if we look at the diagram, y goes down 6 as x goes across 8. So we have minus 6 on 8, which simplifies to minus 3 on 4. We've got the slope. So the equation of this line then is y equals minus 3 on 4x, mx, plus c, the y-intercept is 6. All right, and so then, if we take any x value, like this rectangle could have any shape, right? We could draw this rectangle like this, okay? The point is it's bound by the line. And so if we have some x value x, then the y value is equal to minus 3 on 4x plus 6, because the y value of any point on this line depends upon the x value. All right, so we have the y value, and the x value is just some arbitrary x. It's defined, point B is defined as x, and if point B is x, then the y value we've said is minus 3 on 4x plus 6. So that means the area of this rectangle then, if we take this rectangle out, doesn't matter its size, but it has a base of x and a y value of minus 3 on 4x plus 6. And so that means the area of this rectangle is x multiplied by minus 3 on 4x plus 6. And we can distribute the x there if we want to, but fine to leave it like that as well. So that's the area of the rectangle there. All right, really good. So that's question 8 complete. So that's the first part of the booklet, and then we've still got some logarithms and unit circle to get through as well. So excellent work so far. Okay, let's make a start on the logarithms part then. So we'll just get straight into this. I think I might even go vertical today. See how we go. We can track along as we're doing it. So in the first one we have, so this is review set 13a, question 1a. Now we have log of the square root of 10. So we need to, it's a logarithm in base 10, we need to express it as a single power of 10, and then it just simplifies to the power. So that's A. Let's move on to B. We have log of 1 on the cubed root of 10. And so we need to express this as a single power of 10. We'll write it as log of 1 on 10 to the power of a third. Okay, so cubed root is the power of a third, which simplifies to log of 10 to the minus a third. We've expressed it as a single power of 10, and so now it would simplify to the power, which is negative a third. On to C, we have log of 10 to the A times 10 to the B plus 1. Now these have the same base, which means we can add the powers together. So this would become log of 10 to the A plus B plus 1. It's expressed as a single power of 10, which means it will simplify to the power. So that's question 1. Let's have a go at question 2. We have log in base 4 of 64. So in order to simplify it, we need to express this number as a power of 4, right? 64 as a power of 4. So what that is that's going to be 4 to the power of 3. So we know 4 times 4 is 16, and 4 times 4 times 4 is 16 times 4 is 64. So we've expressed it as a single power of 4, and so it'll simplify to the power. On to B, we have log in base 2 of 256. Now, 2 to the, it's helpful to know these, but 2 to the 6, so what do we have? 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, so that means 2 to the power of 8 is 256. We express it as a single power of 2, and so then it will simplify to the power, which is 8. We have log in base 2 of 0.25. Now this is the same, decimals can be a bit tricky, but this is the same as 1 divided by 4. 1 divided by 4 is 0.25, which is 1 on 2 squared, which is 2 to the minus 2. We've expressed it as a single power of 2, and so it will simplify to the minus 2. So we've got 2ABC. Let's move on to D. We have log in base 25 of 5. So we need to express this number, 5, as a power of 25. Well, 25 is, 5 is the square root of 25, isn't it? So this can be one way we could think about it. And so what that is 25 to the power of a half. We've expressed it as a single power of 25, and so it would simplify to the power. So that's D. On to E, we have log in base 8 of 1. Now, anytime you see a 1, think that's that base to the power of 0. Any number to the power of 0 is 1. So log in base 8 of 8 to the 0 would simplify to 0. We have log, so that's E, we're up to F. We've got log in base 81 of 3. All right, so 3 3 to the power of 4 is 81. All right, so what that means is what we can do is put both sides to the power of a quarter. So 3 is 81 to the power of a quarter. All right, so that's a good way to think about the relationship there. If I want to get 3 by itself, I'm putting both sides to the power of 1 on 4. And so what that means is we can express it like this: log in 81 of 81 to the power of a quarter. We've expressed it as a single power of 81, so it simplifies to the power. Okay, then we've got G, we've got log, log of 9, log in base 9 of 0.1 recurring. Okay, so 0.1 recurring is the same, you're not expected to know this by any means, that's pretty nasty. It's the same as 1 divided by 9, which is the power at the bottom's 1, so we bring it to the top, that's 9 to the minus 1, and then expressed as a single power of 9, so it will simplify to the power, which is minus 1. All right, so that's quite a tricky, nasty one. And then lastly, H, we have log in base k of the square root of k. So this time we don't even have a number. That's absolutely fine. The same techniques apply. So this is going to be log in base k of k to the power of a half, and that will just simplify to be, we've expressed it as a single power of k, and so it simplifies to half. So that's question 2. I reckon we can fit question 3 in, because in question 3 we're just using our calculator. Question 3 says use your calculator to evaluate to 3 decimal places. So the first one is log 27. So I'll just go into my run mat. We've got log 27, type it in. 3 decimal places means we write down 4, 1.4313, and we round the 4th one. Okay, in B we have log of 0.58. All right, put that in the calculator. We've got minus 0.2365, and the 5 will round, minus 0.237. So we want 3 decimal places, so that means we write 4 and round the 4th. So we've got A, we've got B, we've got C here is log of 400. Type that in, log 400, and we've got 2.602. 0 rounds down, so we have 2.602, and then lastly we have ln of 40, so a natural logarithm, and so ln is right in the middle of the keyboard. Ln of 40, that's going to be 3.6888, so 4 decimal places, the 8 rounds up, 3.689. all right, so that's question 3. Very good. Let's move on to question 4 then. Okay, so what we're going to be doing in question 4 is using some of these log rules. So remember, we've got a ln b is the same as ln b to the power of a. We've also got ln a plus ln b is ln of ab, and we've got ln a take ln b is ln of a on b. All right, so they're the ones we're going to be using here. So first up we have, so this is question 4a, we've got 4 ln 2 plus 2 ln 3. The first thing we need to do is take that power to the top there. So that's going to be ln 2 to the 4 plus ln of 3 squared. Now 2 to the 4 is 16 and 3 squared is 9. And then we can bring them together. That's ln of 16 times 9. So it's at 160. That's going to be 151. Okay, on to B. We have half ln 9 take ln 2. So half of ln 9, firstly let's take that power to the top, that makes it ln 9 to the half, and 9 to the half is the same as the square root of 9, and the square root of 9 is 3, and then we have ln a take ln b, so it becomes ln of a on top of b, all right, using our last law there. Okay, let's move on to C then, which is 2 ln 5 take away 1. Let's do it here. We have 2 ln 5 take away 1. Now before we can express these as a before we can bring them together as a single logarithm, that's what it wants us to do, bring it together as a single logarithm, we need to express this as a logarithm in base e. And so what this one is this is ln of e to the power of 0, right? Because any number to the power of 0 will be, this is ln e to the 1. Because, so I'll just write it out first and then I'll explain why. ln e to the 1. ln e to the 1 simplifies to be the number 1, right? So that can be quite tricky. Like looking at it from here, we can see clearly it goes from there to there, but it's difficult to anticipate what does 1 become when it's a logarithm of base e. So they can be a bit tricky to see. Nonetheless, let's proceed. Let's move the 2 up the top here as well. So that's going to give us ln of 5 squared. Take ln of e to the 1. 5 squared is 25. And then we've got ln of a, take ln of b. We can just write it as ln of 25 on top of e. You can put e to the power of 1, doesn't really matter. It's fine like that as well. So that's question C. Very good. And then last one, we have simplify, and we've got a quarter of ln of 81. So they want us to simplify this. All right, well, all we're going to do there is move the quarter to the top then. We have 81 to the power of a quarter, and we even saw before that 81 to the power of a quarter is 3. So that would simplify to ln 3. Really good. Okay, so that's question 4. Let's move on then to question 5, which is pretty similar. We're writing as a single logarithm. We have log 16, so this is 5a. We have log 16 plus 2 log 3. So log 16 plus 2 log 3, this will become log of 16 plus log of 3 squared, which is log of 16 plus log of 9, which is log of 16 times 9, and that's log of 151. Okay, so just processing that there, that's 5a. Let's move on to 5b. We have log in base 2 of 16, take away 2 log in base 2 of 3. All right, so we're going to bring these together. They have the same base, but first let's simplify this. So we can take that power to the top. They want us to express it as a single logarithm, right? So that's going to be log in base 2 of 3 squared, which is 9. I'll do that in one set. When you move the 2 there, it becomes 3 to the power of 2, and 3 to the power of 2 is 9. Then we have log of a, take log of b. We can write that as log of a on top of b. 16 on 9 won't simplify, so we'll leave that as is. So that's question 5b. Let's move on then to 5c. This will be the last one for this page. We have 2 plus log in base 4 of 5. So if we want to write this as a single logarithm, that means we need to express this with a logarithm of base 4. So at the moment, the logarithm in base 4 of 4 squared, that would simplify to 2, right? So one alternative way we can express the number 2 is the logarithm in base 4 of 4 squared. This part remains here. Now 4 squared is 16, so we could express it like this. And then they have the same base, so it's log of a plus log of b. We can bring it together. It's log of 16 times 5, and that's going to be log in base 4 of 80. Really good. So we've expressed that there as a single logarithm. 4 is not a power of 80, so we're fine to just leave it like that as well. All right, so that was question 5c. Let's move on to question 6. All right, so question 6 is quite a tricky one. We have, question 6, we have a number of patterns that we're trying to use to crack these in terms of a and b. So if we've got log in base 5 of 36, all right, and we've also got that a is log in base 5 of 2, and b is log in base 5 of 3. Right, so I'd be looking at that and going, that's the same as like 9 times 4, right? So we can break it up like this. That's the same as 9 times 4. which is log in base 5 of 9 times plus log in base 5 of 4. So we can split it up into those parts, and that's going to be log in base 5 of 3 squared, and this part would be log in base 5 of 2 squared. And log in base 5 of 3 squared, well, log in base 5 of 3 is b, so this whole part is b squared, and log in base 5 of 2 is a, so this whole part is a, with the squared there as well. So all we're doing is expressing these in terms of a and b. It's a nice problem solving activity. All right, let's move on to b then. We have log in base 5 of 54. So for 54, we're looking for some sort of multiple that these are going to have in common. 9 times 6 is 54, isn't it? 9 times 6. So one way we could write that, or so like 9 times 6, and 9 times 6 is the same as 3 times 2. So that's where I'm getting at, or you could even treat it as, yeah, I think we're going to have to separate it anyway. So 9 times 3 times 2. So now we can see that's a base of 3, that's a base of 3, that's a base of 2. So let's split that up then. That's log in base 5 of 9 plus log in base 5 of 3 plus log in base 5 of 2. And we know this one is log in base 5 of 3 squared. This is b, this is a, and so then this is b squared. All right, log in base 5 of 3 is b, so we have b squared. Log in base 5 of 3 is b, so we have b squared plus b plus a. So that will be our answer for question 6b. All right, 6c. In 6c, we have log in base 5 of 8 root 3. All right, so 8, that's 2 to the power of 3, that's 3 to the half. So let's split both of these up first. We're just going to make it log in base 5 of 8 plus log in base 5 of root 3. All right, split the terms up and express this as a power of 2 and express this as a power of 3. All right, and we know log in base 5 of 2 corresponds with a, and log in base 5 of 3 corresponds with b. So we've expressed it in terms of a and b. That's part C. On to D, we have log in base 5 of the square root of 6. Now the square root of 6 is the same as 3 times 2, the square root of 3 times 2, which is the same as the square root of 3 times the square root of 2. We'll split both of those up, so we have log in base 5 of root 3 plus log in base 5 of root 2. So this is 3 to the half, this is 2 to the half, and we know log in base 5 of 3 is b, and log in base 5 of 2 is a, and so we've expressed it in terms of a and b. All right, so that was D. Let's move on to E. And just resuming, we've got E, we have log in base 5 of 20.25. All right, so 20.25, that's the same as 80 divided by 81 divided, that is really tricky. So that is 81 divided by 4, all right? And so we'll write that as log in base 5 of 81, take log in base 5 of 4, split it up, and so this part is 2 squared, and this part is 3 to the power of 4. And log in base 5 of 3, that simplifies to b, so we have b to the 4, and here we have a squared. Okay, last one then for these ones, they're a little bit tricky, aren't they? We have log in base 5 of 0.8 recurring, 0.8 reoccurring. So that's 0.88888, and we have some combination of 3 and 2. So that's going to be 8 divided by 9. So very tricky. Again, don't expect you to know that. So that's going to be log in base 5 of 8, take log in base 5 of 9, which is log in base 5 of 2 to the 3, take log in base 5 of 3 squared. This part is a to the power of 3, this part is b squared. All right, so they're quite tricky. That's all of question 6. So yeah, they are quite tricky ones, but just expressing it in terms of A and B and rearranging and so forth. All right, I'm going to stop there, have a bit of a break, and I'll resume shortly for question 7. All right, we're back. We're going on with question 7. So in question 7, we have question 7a, we have the logarithm in base 2 of x is equal to minus 3. So whenever we have a logarithmic equation like this, we're trying to get x by itself, right? And the way we're going to do that is raise the base to the power of both sides. So we're going to have 2 to the power of log base 2 of x and 2 to the power of minus 3. And what this allows us to is, because the base is 2, we've got 2 to the power of that logarithm, it gets rid of the logarithmic component. And so we're just left with x. X is 2 to the minus 3, which we could write as 1 on 2 to the power of 3 or 1 on top of 8. That's going to be the solution to this one. So similarly for b then, we have log in base 5 of x is equal to 2.743. So we're going to raise 5 to the power of both sides this time to get rid of the 2.743, and what that allows us to do, the 5 gets rid of the logarithm, we're left with x is 5 to the power of 2.473, and we could put that in our calculator and evaluate that. On to c. In c we have log in base 3 of x equals minus 3.145, so therefore put 3 to the power of both sides because the logarithm's 3. 3 to the power of minus 3.145, and so here the x will be left by itself, 3 to the power of minus 3.145. That's our solution for C. Excellent. Let's move on to question 8. And in question 8, we're solving exponential equations. So here we have 2 to the power of x is equal to 50. We want to get x by itself. We're going to perform the logarithm of both sides. And then we're going to move that x out the front and then divide both sides by ln2. So we have ln 50 divided by ln2. That's the solution. Now that is not the same as ln of 50 on 2. Okay, so don't go confusing that. We have the logarithm of 50 divided by the logarithm of 2. That's our answer to question 8 part A. Okay, on to 8 part B. In 8 part B we have 7 to the power of x is equal to 4, and we want to solve for x. We're going to perform again the natural logarithm of both sides, move the x down, and then divide both sides by ln7 to get x by itself. On to C, we have 0.6 to the power of x is equal to 0.01. We'll perform the natural logarithm of both sides again. Move the x in front, and then divide both sides by ln of 0.6. Excellent. So that's our answer to C. Let's move on to question 9 then. In question 9 we have suppose logarithm in base A of B is equal to x. Find in terms of x the value of logarithm of A of 1 on B. Okay, so if this is x, what it wants us to find is what is the logarithm in base A of 1 on top of B. All right, so if we take this, let's take this component. This can be a tricky question. You're like, what is this even talking about? One way we could express this, right, is we could move that b to the top, and so we could make it like this. It's the logarithm of a and b to the minus 1. Then we can move the negative out the front. Negative logarithm in base a of b, and we know that the logarithm in base a of b is x, so this part is x. So this component can be expressed as negative x. expand it in terms of x. All right, question 10, we have a population of seals is given by, and we've got this equation here. Find the time required for the population to double. So if we're using logarithms, all we'll do is we'll go the population is equal to 80 times 1.15 to the power of t. And we need that to double. So that's when the population equals 160. All right, so the initial population is 80. And we know that because when time is 0, we've got 80 seals. Divide both sides by 80. We would have 2. Perform the natural logarithm of both sides. Move the t out the front. Divide both sides by ln of 1.15. That's going to be our solution, and we can put that in our calculator to determine the exact value of t. Part B says, find the percentage increase in population during the first 4 years. Okay, so the percentage change, all right, is going to be the new, take away the old, divided by the old, times 100%. Okay, so that's how much has it gone up. And so for question 10b, that's going to be, so we need during the first 4 years. So the new is going to be when time is 4, and the old is going to be when time is 0. So we know when time is 0, the population of seals is 80, and when time is 4, let's use our calculator. 80 times 1.15 to the power of 4. There are 139.9. We'll round that to 140 seals. So 140, take 80, divided by the old amount was 80, and then multiplied by 100%. 140 take 80 is going to be 60 on 80, 6 on 8, and that's, excuse me, we've got 75% anyway. Oh my gosh, can't operate a calculator. 75%, it's going to work out to be 6 divided by 8, it's 0.75, and multiplying that by 100, 75% increase. All right, so how did we do that? We found the population when the time was 4. We've got the population when the time was 0. We plug that into the population, the percentage change formula, and we've got our 75%. Okay, so that's question 10, and then we've got this question 4 here, don't we? We've got some simplifications of natural logarithms. So we have ln of e root e. So we're using this rule here, ln e to the x simplifies to x. So we need to express this as a single power of e, right? So it's going to be e times e to the half, and e by itself is e to the power of 1. And so this will collect to 1 plus a half is 3 on 2, 1.5, same thing. And then that will simplify. We've expressed it as a single power of e, so it simplifies to 3 on 2. So that's 4a. Let's move on to 4b. We have ln of 1 on e cubed. We can express this as ln of e to the minus 3, which will simplify to minus 3. On to c, we have ln of e to the 2x. It's already expressed as a single power of e, so that will just simplify to 2x. And d, we have ln of e on top of e to the x. Now e by itself is e to the power of 1, so we're going to write this as, in terms of index laws, ln of e to the 1 take x, okay, top power take the bottom power. We've expressed it as a single power of e, so it can simplify to 1 take x. Just on this last one, I'll point out a connection. Obviously with log laws, remember if we have ln of a on b, we can write it as ln of a take ln of b, right? And we know ln e to the 1 simplifies to 1, and ln e to the x simplifies to x. Same answer, but just pointing out relationship there. Okay, so that's the end of our logarithms revision. I'm going to stop there and we'll resume shortly with the unit circle revision. All right, here we are for the unit circle revision. We've got, we're going to start straight away with converting to radians in terms of pi. So I'm just going to draw this up quickly. We've got degrees, we've got radians, and in order to convert to radians, we multiply by pi on 180, okay? And if we're converting from radians to degrees, we multiply by 180 on pi. So that's just the rules that we have there. So all of these we can just do in our calculator. So 30 degrees multiplied by, we're going from degrees to radians, we multiply by pi on top of 180, and we've got 1 on 6 pi, or just pi on 6. Okay, and you can just go through and do all of these, 5 pi on 6, etc. This will be pi on 9. All right, go through and get them done. Same here, if we're converting from radians to degrees, we're multiplying by 180 on pi. So I'll take the first one, we've got 7 pi on top of 6, and we're going to multiply that by 180 on top of pi, 210 degrees. And you can just go through and so forth, 135 degrees, etc., etc. Okay, let's move on to question 4. Prove that for theta in radians, the arc length is AB. Okay, so what we're going to do, we'll take the arc length in terms of degrees first, right? So the arc length, now remember for a circle, the circle has circumference 2 pi r, and so that means an arc length is going to be the angle on 360 multiplied by 2 pi r. All right, now this is expressed in degrees, and so if we wanted to convert that to radians, what we're going to do is we're going to multiply the angle by 180 on pi. All right, so that means we've got theta multiplied by 180 on top of pi, all on top of 360, and then that's multiplied by 2 pi r. We'll just process this. We're going to have at the top here 180 theta on top of pi, on top of 360, and 360, like if that's a fraction, that's on top of 1, and then multiplied by 2 pi r here. Now the reason I write it like this is because when we have A on B on C on D, okay, A on B, this is going to pop up a fair bit, it will simplify to AD on top of BC. When we have one fraction divided by another, it's A times D divided by B times C. So the reason I put the 1 at the bottom is because it's 180 theta on top of pi times 360, or 360 pi, we can write it as. And then we have here times 2 pi r. Now, this will simplify a little bit because we have here pi at the top, pi at the bottom. That can cancel. We also have 180 divided by 360. 180 divided by 360 is the same as half, and we have half times theta times 2 times r. Okay, so I've said 180 divided by 360, that's the half. There's the theta, there's the 2, and there's the r. Now half and 2 will cancel, and so we're just left with theta r, or r theta. And so the arc length is r theta. All right, tricky one. Okay, then we're going to do the same for the area. So the area of a circle is pi r squared, which means the area of a sector would be the angle for that sector multiplied by pi r squared. All right, and remember again, we're doing the angle in radians, so we would multiply it by, we're converting from degrees to radians, so we would multiply it by pi on 180. So we're going to have pi on 180, excuse me, at the moment it's in degrees and we wanted to get it to radians, so we're multiplying it by 180 on pi. If I put the eraser. So we're multiplying that by 180 on pi. So we have theta times 180 on pi, all on top of 360, and then here times pi r squared. We're going to have the same thing, basically the same thing occur. We have 180 theta at the top, on top of pi, on top of 360, on top of 1, times pi r squared. AD on BC, so this becomes 180 theta on top of 360 pi times pi r squared. Pi at the top, pi at the bottom will cancel. 180 divided by 360 is half, so we have half theta r squared, which we've got here, half theta r squared. Very good. Find the arc length and sector area for a radius of 5 centimeters and an angle of 2 radians. So let's go through both of these using the formulas that we have then. So we have a radius of 5 centimeters and an angle of 2 radians. That means the arc length is going to be, the radius is 5 multiplied by the angle is 2. The arc length is going to be 10 centimeters. So that's 4A part 1. And then on to 4A part 2, 4B. So we've done the arc length, we need the area. Find the area. The area is half the radius squared times the angle. So that's going to be half the radius squared multiplied by the angle. So that's, well, we've got 2.5, we'll cancel, 5 squared is 25. So the area of this sector is 25 centimeters squared, and it has an arc length of 10 centimeters. All right, on to part B. On to part C, sorry. Find if a sector has a radius of 10 centimeters and an arc length of 13, find its area. All right, so we've got a radius of 10 and an arc length of 13. So what that means, right, it looks something like this. We've got 10 and we've got 13, but we don't have the angle here, theta. Now, if we have r times theta is the arc length, well, that means 13 is equal to 10 times theta, which means theta, well, 13 divided by 10 is equal to theta. So we've determined the value of the angle, right? We've isolated theta by itself, and we can put that into the area formula. Now the area is half times r squared times theta. So that's going to be half times 10 squared times 13 on 10, which is the same as 1.3, by the way. So it's going to be 100. We have 50, half of 100 is 50. 50 times 1.3. And so we'll just put that in your calculator, or you can work it out if you want, but we'll get 65. There we go. 65, and for a unit, we've got centimeters squared. So that's question 4, converting. So we proved both of these, and then we've gone on to find the areas and lengths and so forth. All right, let's move on to this part here where we've got applications of the unit circle. Copy and complete. So let's just fill it in according to our unit circle here. Firstly, we have degree measure. So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And if we look in the first quadrant, the angle goes from 0 to 90. In the second quadrant, it goes from 90 to 180. In the third quadrant, 180 to 270. And in the fourth quadrant, 270 to 360. So you can see 0 to 90 degrees, 90 degrees to 180, 180 to 270, and 270 to 360. I've done some terrible notation there, but that's okay. In terms of radians, we're just making the same statement, but in terms of radians. So the second quadrant goes from pi on 2 to pi. The third quadrant goes from pi on 2 to 3 pi on 2. And the fourth quadrant goes from 3 pi on 2 to 2 pi. All right, now we're answering, are they positive or negative? So if we look in the second quadrant, okay, that's here, we can see we've got negative x values, which means the cosine values are negative, but the y values are positive. Now tan is sine divided by cos. So if we have a positive divided by a negative, the result will be negative. In the third quadrant, we have both negative x and negative y. So that means negative cos and negative sine. And if we have a negative divided by a negative, we'll have a positive. So tan values are positive. And in the last quadrant here, we have positive x but negative y. So positive cosine values, negative sine values, which is going to leave us with negative tan values. And you can remember, all students talk cool. So all trig ratios are positive, only sine is positive, tan is positive, and only cos is positive. Very good. Okay, use a unit circle diagram to find sine of alpha, cos of alpha, and tan of alpha for these different values of alpha. So we've got the unit circle diagram there, and I'll do it on this one. So we'll just start here, I think. So we have firstly sine of pi on 3. So what we're doing, we go sine is the y value, we find the angle pi on 3, and we say what's the sine of pi on 3, what's the y value? Root 3 on 2, okay? Cos of pi on 3, all right, that's the x value. The x value at pi on 3 is half. And then tan of pi on 3, well, that's just sine divided by cos. So the tan value of pi on 3 will be root 3 on 2 on half. Remember, A on B on C on D, A on B on C on D is AD on BC. AD on BC becomes 2 root 3 on 2, 2 at the top, 2 at the bottom will cancel. The tan value is root 3. Now, all of these, you can process them using your calculator, but we're just using the same process. So I'm going to do A, and I might skip ahead to E. All right, let's go ahead. So we've done A, and let's jump ahead to E. Okay, if we go for sine of pi, I'm saying when the angle is pi, what's the y value? 0. What about the x value? Cos of pi is -1. And what about the tan value? Well, tan is sine divided by cos, so 0 divided by -1 is 0. The tangent value is 0 at that point. So that's all good for question 1. Let's move on to question 2, and let's do a little bit of this using the unit circle. I think this is probably a better application of it. So I'll get a new page. So we have cos of 3 pi on 4. Take away 2 sine of pi on 4. All right, so we're going to look at 3 pi on 4 on our unit circle. Find the angle for 3 pi on 4. Why doesn't this one have it? That's not very good. This unit circle is missing these multiples. All right, so these are the multiples of, so here we have pi on 4, here we have 3 pi on 4, here we have 5 pi on 4. And at these points, the x and y values are the same. They're 1 on root 2. And same here. This is going to be -1 on root 2 and +1 on root 2. Here they'll both be negative. And here cos will be positive, sine will be negative. All right, so cos of 3 pi on 4, if we go to 3 pi on 4, the x value is 1 on root 2. And then we have take away 2 lots of sine of pi on 4. So that means 2 lots of, now if we go to pi on 4, the sine value is 1 on root 2. So if we have, cos of 3 pi on 4 is -1 on root 2. So if we have -1 on root 2, take away 2 lots of 1 on root 2, that's going to leave us with -3 lots of 1 on root 2 or -3 on root 2. Okay, either way is fine to write it. Now if you type that in your calculator and you've got it set in radians, it will spit out the answer for you as well. But it's helpful to know how to use the unit circle. Okay, 2 sine of 7 pi on 6 times cos of 5 pi on 6. 2 sine 7 pi on 6 multiplied by cos of 5 pi on 6. So we're going to 7 pi on 6, that's here. Sine of 7 pi on 6 is -1/2, so we have 2 times -1/2, and cos of 5 pi on 6, the x value, is -√3 on 2. So whenever we're multiplying these, right, it's just the top times the top times the top. So at the top we're going to have 2 times 1 times √3, that's just 2 √3. And at the bottom we're going to have 2 times 2, which is 4. And we have a negative times a negative, so the result is going to be a positive. Now we can leave it like that, or you can see we've got 2 at the top, 4 at the bottom. So that can simplify to √3 on top of 2, right? We have 2 times 2 at the bottom, we can cancel one of the 2's. All right, √3 on 2 is our answer for B. On to C, we have 2 take away sine squared of 5 pi on 4. Now that means sine of 5 pi on 4, and then it's squared. So sine of 5 pi on 4 is here, the y value is -1 on root 2, so we have 2 take away 1 on root 2 squared. That's going to be 2 take away 1 on 2, which is 2 take a half, which is 3 on top of 2, 1 1/2. All right, so that's our answer for C. If we go to D, we've got tan squared of pi on 6 plus tan squared of pi on 3. So we don't have the tan values, which means we need the sine and cosine values in order to determine it. So if we've got pi on 6, all right, that's going to be here. And remember, tan is sine divided by cos. Tan is sine divided by x. So the tan value of pi on 6 is going to be half divided by root 3 on 2. The y value divided by the x value, half divided by root 3 on 2. And so we'll have AD on BC again. A times D is 2. 2 times root 3. And so that will simplify to 1 on root 3. We have 2 at the top, 2 at the bottom, that can cancel. And so tan of pi on 6 is 1 on root 3, but it's squared. So we'll keep that squared there. And then we have tan of pi on 3. Okay, that's going to be up here, pi on 3. Again, sine divided by cos. So that would be root 3 on 2 on top of 1 on 2. AD on BC. AD on BC gives you 2 root 3 on top of 2. 2 at the top, 2 at the bottom can cancel. And we're just left with root 3. So tan of pi on 3 is root 3. And that component is squared as well. So this is going to leave us with a third. And this is going to leave us with 3. 3 plus a third is 3 1/3. Or we can think about it as, what's that, 9 on 3, 10 on top of 3. That's our answer to D. Okay, we'll keep going then. We've got E. E is 1 take sine of pi on 6. And that's divided by 1 plus sine of 11 pi on 6. Okay, so sine of pi on 6, if we go to pi on 6, the sine value is half. So at the top we have 1 take away a half. And sine of 11 pi on 6 is here. That's minus half. So that also becomes 1 take half. And so what we have then, we have this 1 take half at the top, 1 take half at the bottom. Same thing at top and bottom. It's going to simplify to 1. Or you can think of it as 1 take a half is a half. And 1 take a half is a half. So half divided by half is 1. All right, so that's what E will come out as. So our last one then is F, where we have 8 sine of pi on 3 multiplied by cos of 5 pi on 6. 8 sine of pi on 3 multiplied by cos of 5 pi on 6. So we'll look at our unit circle. We'll go to pi on 3. Here it is. The sine value is root 3 on 2. So we have 8 times root 3 on 2. The cos value of 5 pi on 6 is negative root 3 on 2. And then we're going to multiply this out together. So at the top, we're going to have 8 times root 3 times root 3. That's going to be 8 times 3. That's going to be 24 at the top. And we've got positive terms and then there's negative. So the negative is going to hang out the front. And at the bottom, we've got 2 times 2, which is 4. And 24 divided by 4 is 6. So our answer to F will simplify to be negative 6. All right, guys, here we are. We're back with our trig and unit circle revision. And we're going to make our way through question 3. I've also taken off this unit circle, and I'm going to re-add this one to the booklet. This is a good one because it tells us the cosine, the sine, but also tells us the tangent values, and it has all of the angles included. Ours was missing a few. So let's get straight into this exercise then. We're on question 3 of our applications of the unit circle, and our first one is sine t equals minus half. When does sine of t equal minus half? Okay, so this is question 3, part A. And we're asked to solve this between 0 and 4 pi. So that means 0 is less than or equal to t. T is our variable. Sometimes we use x, sometimes we use theta, sometimes we use t. And so this means we're considering 2 revolutions of the unit circle. So what I'm going to do, sine is the y value. I'm going to look at the unit circle and go, when is the y value negative half? So if you think, here's the point of origin, right? The y value is going to be negative half about here. Okay, if this is the y value, here's y minus 1, here's y is negative half. And so then the points on the circle that corresponds with, you can see here, has a y value of minus half, And we can see over here as well, y value of minus half. So that means our solutions are, for the first revolution, 7 pi on 6. Okay, I'm getting that from there. 7 pi on 6 and 11 pi on 6. Now that's within the first revolution of the unit circle, right? That's from 0 to 2 pi. We've gone around once, 0 to 2 pi, but we go around again another time, which means we're going 360 degrees or 2 pi past each of these solutions as well. So that means we have 7 pi on 6 plus 2 pi and 11 pi on 6 plus 2 pi. That's all of our solutions, right? Now we can simplify that using our calculator. 2 pi, like if we're going to do this manually, 7 pi on 6 plus 2 pi, we need them to have the same denominator. And so one way we can express 2 pi is that it's 12 pi divided by 6, right? So these solutions become 7 pi on 6 plus 12 pi on 6. Those are the same, different way of expressing it. And now that they have the same denominator, you can add the numerators together. So if you type this into your calculator, it'll come out with 19 pi on 6. And similarly, this one will be 23 pi on 6. All right, so we've got 4 solutions, 7 pi on 6, 11 pi on 6, 19 pi on 6, and 23 pi on 6. They're the values of t for which sine of t is negative half. All right, let's move on to b. In b, we have cos of t equals 1 on root 2. Now it's worth stating 1 on root 2 is the same as root 2 on 2. Now that is something you do need to know. Both of those will pop up. So we have to be flexible and we have to be able to observe both solutions. And again, we're saying from 0 to 4 pi. That's the constraint for all of these questions. So cos is the x value and root 2 on 2 or 1 on root 2, we're having a look. Here the x value, positive root 2 on, or 1 on root 2, there and down here. I've expressed it on this unit circle. We've expressed it using both forms so that we're familiar that they're the same value, root 2 on 2 and 1 on root 2. All right, so that occurs at the angle pi on 4 and 7 pi on 4. Now that would be within the first revolution of the unit circle. So then we need to add 2 pi again onto pi on 4 plus 2 pi, and 7 pi on 4 plus 2 pi. All right, in order to add these ones together, they must have the same denominator. You can type that in your calculator and it will spit out the answer. But 2 pi as a fraction with a denominator of 4 would be 8 pi on top of 4, right? So we've got, pi, I'll write out the solutions like this, pi on 4, 7 pi on 4, pi on 4 plus 8 pi on 4. Okay, 8 divided by 4 is 2 pi, so those are the same. And then here 7 pi on 4 plus 8 pi on 4. So I'm just putting in this step as a sort of segue to our final answer where we've collected it. Pi plus 8 pi is going to be 9 pi. And we can do that in this step because they have the same denominator. And here 7 and 8 is 15 pi, all on top of 4. So the values of t, for which cos of t is 1 on root 2, or root 2 on 2, these mean the same thing. They're both ways of expressing it. These are the values of t that satisfy that. Okay, very good. So that's question B. Let's move on then to C. And in C, I'm going to do it here on the right. We have tan squared of t is equal to 1 on 3. All right, there's going to be lots of solutions here. Now, firstly, what this means is it means tan of t equals 1 on 3. So if we're tan of t, squared is equal to 1 on 3, that's what that notation means. It's tan of t squared. So that means we need to square root both sides. So we would get tan of t is the square root of 1 on 3, which is the square root of 1 on the square root of 3, which is plus or minus 1 on root 3. Okay, so what did we do there? We had square root of 1 on 3. We split the surd. The square root of 1 is plus or minus 1, and we'll leave the square root on the 3 there. So we're saying, when is the tan value? So all we've done is break this down to get tan of t by itself. Tan of t is plus or minus 1 on root 3. We need to find the values of t for which this is true from 0 to 4 pi. Okay, so if we consider the first revolution, when is the tan value? 1 on root 3. So here it is. That's the tan value, 1 on root 3, and my first angle is pi on 6. And then it's just going to be mirrored that, right? We go all the way around, we have negative 1 on root 3. Now this is one of the solutions because we have positive 1 on root 3 or negative 1 on root 3 because of that square root. So we're considering both the positive and negative solutions of tan. So we have 5 pi on 6, we're going to have 7 pi on 6. All right, there's the tan values out here. So the tan values are next to the coordinate. And lastly, 11 pi on 6. So we've got all of those. That's within the first revolution, right? But there's another 4 solutions because we need to go past each of those again. So the other 4 solutions then are going to be pi on 6 plus 2 pi, 5 pi on 6 plus 2 pi, 7 pi on 6 plus 2 pi, and 11 pi on 6 plus 2 pi. Now 2 pi as a fraction is 12 pi on 2. So that's what we're adding to each of these solutions, right? So to list all of the solutions in ascending order, we have pi on 6, 5 pi on 6, 7 pi on 6, 11 pi on 6. They're the first 4 in the first revolution. And then the later 4, we have pi on 6 plus 2 pi. Excuse me, that should be 12 pi on 6. Pi on 6 plus 2 pi, that's 12 pi divided by 6. Same denominator, so we can add them. That's 13 pi on 6. This will be 17 pi on 6. Come down here, we'll have 7 pi plus 12 pi, 19 pi on 6, and we'll have 11 pi. 11 plus 12 is 23 pi on 6. Those are all the solutions for when the tan value is positive or negative 1 on root 3. Very good, that's A, B, C. Let's move on then to D. And in D we have sine of t equals root 3 on 2. All right, so looking at our unit circle, when is the y value root 3 on 2? Root 3 on 2 is about 0.8, so that's going to be up here somewhere. Y is root 3 on 2, y is root 3 on 2. So our solutions, pi on 3 and 2 pi on 3, that's within the first revolution. And then we're going past each of those again. So we're adding 2 pi to each of those solutions, pi on 3 plus 2 pi, and 2 pi on 3 plus 2 pi. Just simplify those then. Pi on 3, 2 pi on 3. Put that in your calculator, do the fraction operation manually. That's going to be 6 pi divided by 3, so that'll be 7 pi on 3 when we add it together, and this will be 8 pi on 3. They're all the solutions within the first 2 revolutions that satisfy the value of t for which sine of t is root 3 on 2. Very good, that was D. Let's move on to E. So for E we have tan of t equals negative root 3. So we're saying when is the tan value negative root 3? So the tan value, remember, they're on the outside of the coordinates. Here's the first one, and the value is 2 pi on 3. And then the second one, so that's negative root 3, and we go all the way around. There's positive root 3. Here, 5 pi on 3. The tan value is negative root 3. So there are our 2 solutions within the first revolution, but remember we're going from 0 to 4 pi, so that means we're doing 2 revolutions of the unit circle. So that means our other 2 solutions are going to be each of those plus 2 pi, right? 2 pi on 3 plus 2 pi, and 5 pi on 3 plus 2 pi. And so if we simplify those, we'll have all the solutions, 2 pi on 3, 5 pi on 3, we're going to have 2 pi on 3 plus 6 pi on 3, that's going to be 8 pi on 3, and then 5 pi on 3 plus 6 pi on 3, 11 pi, all on top of 3. All right, so they're all the values of t for which tan of t equals negative root 3. On to F. Okay, so we've got one more, and this one is 4 cos squared of t equals 3. So what this means, we're going to have to break this one down first. It means 4 times cos of t squared equals 3. Our first thing is going to be to divide both sides by 4. So we have 3 on 4, and then we will square root both sides to get cos of t by itself. And that leaves us with plus or minus root 3 on top of 2. So what have we done there? We square root both sides. We divide up the surd, the square root of 4 is plus or minus 2. And so we're looking for when is the cos value. All right, so what we've done there, the reason we've done all that is because we're trying to get cos by itself. We get cos by itself, and so now we can look at the unit circle and we go, what are the values of t that make this statement true? When is the cos value positive root 3 on 2 or negative root 3 on 2? So we'll have a look. Cos root 3 on 2 here, multiples of pi on 6. So we've got pi on 6. And then we're looking around, when is the cos value here, over here, negative root 3 on 2, and that corresponds with 5 pi on 6. We have 7 pi on 6, it's negative root 3 on 2, and we have 11 pi on 6. 11 pi on 6. Now that's within the first revolution, so then in order to get the second revolution, we need to add 2 pi to all of those, and 2 pi with a denominator of 6 is 12 pi on 6, right? And so that means I'm going to list all 8 solutions in one go. We'll have the first revolution, 5 pi on 6, 7 pi on 6, 11 pi on 6. And then we'll have the second revolution, so all of these plus 12 pi on 6. So 13 pi on 6, when we add 12 pi on 6 to the first one. We'll have 17 pi on 6 when we add 12 pi on 6 to the second one. We'll have 19 pi on 6 when we add it to the third one, and we'll have 23 pi on 6 when we add it to the last one. So 8 solutions within the first 2 revolutions of the unit circle, for which 4 cos squared of t equals root 3, or breaking it down, cos of t is positive or negative root 3 on 2. Very good. So that is question 3. Let's move on to question 4. So in question 4, there's 2 main strategies we can use to do this one. Let's do one using the Pythagorean identity first. So we have find sine of x given cos of x is negative 2 on 3, and we've got a constraint for the angle. We've got pi on 2 is less than x is less than pi. That's the region for which we're considering. So the first strategy we can use is the Pythagorean identity, which says sine squared x plus cos squared of x is equal to 1. Okay, so that's an identity that you're required to know. Sine squared x plus cos squared x is equal to 1. And so if I put cos x in here, cos x is minus 2 on 3. So I'm going to substitute that where the cos x is, right? So I'm going to have sine squared of x plus minus 2 on 3 squared equals 1. So we're told cos x is minus 2 on 3, so I've put it where the cos x is. And remember, this squared means the cos x is squared. Okay, and then what are we trying to do? We're trying to find sine. So we're just trying to break this equation down for sine of x by itself. Now, 2 on 3 squared, that becomes 4 on top of 9. We square both the top and the bottom, and the negative squared becomes positive. Now we're trying to get sine by itself, so we'll subtract 4 on 9 from both sides. 1 take away 4 on 9. Now you can do that in your calculator, but what's going on again? We need them to have the same denominator. 1 we can express as 9 divided by 9, right? 9 divided by 9, take away 4 divided by 9. And that's going to become 9 take 4, that's positive 5 on 9. Now this is sine squared of x, which means to get sine x by itself, we would square root both sides. So we're going to have sine x is the square root of 5 on 9, which is the square root of 5 on the square root of 9, which is root 5 on 3. And it's positive or negative. So there's 2 solutions. So we have root 5 on 3 or negative root 5 on 3. Now the reason I've written them out like this is because we're constrained. We're given a constraint. And so that means if we think about the unit circle, we're told the solution exists in this region between pi on 2 and pi. Okay, so here's pi on 2, here's pi. The solution exists in this region. Now, in this region, all of the sine values, which are y values, all of the sine values are positive. Okay, the y values are positive in this region, which means we reject the negative solution. It's rejected because this does not exist within the domain of which we're speaking. So our solution is root 5 on top of 3. Very good. So that's 4a. Let's move on to 4b and let's use the other strategy for 4b. It says find tan of x given sine of x is negative 2 on top of 5. And our region for constraint is 3 pi on 2 is less than x, which is less than 2 pi. All right, so we've got sine of x is negative 2 on 5. So what we're going to do with this one is we're going to remember SOHCAHTOA. That's what we learn about with basic trigonometry, right? And so we have sine is O divided by H, cos is A divided by H, and tan is O divided by A. So what that means for us is we've got sine of x is 2 on 5. So that means it's O on H, all right? Sine is O on H. And so the 2 corresponds with O and the H corresponds with 5. Next, we're going to draw a right-angled triangle. Any right-angled triangle, all right? Where we're going to put our theta here and our right angle here. And we're just going to label it, right? So this is my hypotenuse. This is my adjacent side connecting theta and my right angle. And this is my opposite side. So we've drawn our right-angled triangle. Now remember up here we have sine of x is 2 on 5. Now we're not interested in the negative at this stage. That's going to come into play later. 2 corresponds with O. So we'll put the 2 where the O is. H corresponds with 5. So we'll put H where the 5 is. Now we've got an unknown here. We've got this unknown A value, right? We're going to find that. And so using Pythagoras' theorem, we would have A squared plus O squared equals 5 squared. All right? A squared plus B squared is C squared. In this circumstance, A squared plus O squared is 5 squared. Let's rub that out. A squared plus 2 squared is 5 squared. All right, A squared plus 2 squared is 5 squared. And we're trying to get A. We want to know what's the value of this side. So we'll, 2 squared is 4, 5 squared is 25. We'll subtract 4 from both sides. So we'll have A squared is 21, which means A is the square root of 21. Okay? And it could be positive, it could be negative. We'll make a claim later based off the region. Now, the question says find tan. Find tan of x. Well, tan is O divided by A. All right, so we're going to write tan of x is O on top of A. And remember, O corresponds with 2. That's off our triangle. And what's the A value? We found it. A is root 21. So we can write that here. Tan is 2 on root 21. And then we need to go, is it positive? Is it negative? Let's have a look. Well, on the unit circle, remember, all students talk cool. It tells you what ratio is positive. And so here, all the ratios are positive. Here, only sine is positive. In this quadrant, only tan is positive. And so in the quadrant we're talking about, only cos is positive, which means our tan value is negative. So we're going to write tan of x is negative and then reference the region as 3 pi on 2 is less than x, which is less than 2 pi. Very good. So that was B. Let's move on to C. And so you can use either of those strategies, right? You can use the triangle or you can use the Pythagorean identity. I think the triangle is good because it helps you find multiple solutions, and it means you don't have to worry about the tan strategy either. You don't have to worry about rearranging some complex algebraic formula for tan. Okay, so let's go for... So I've just realized I did A and then this one was C. I've done them in the wrong order. So we've got A, we've got C, and now I'm going to do B. All right, so I'm going to do B. So for B, we have find cos of x given sine x is 1 on 4. All right, so we've got sine x is 1 on 4. The region for which we're talking about is the first quadrant, which means everything's positive. All trig ratios are positive. So that's all good there. Now sine corresponds with O on H, remember? So if we draw a right-angled triangle, here's our angle, here's our right angle. We'll label it hypotenuse, opposite, adjacent. O corresponds with 1. So we'll put the number 1 where the O is. 4 corresponds with H, so we'll put 4 where the H is. And using Pythagoras' theorem, A squared plus 1 squared equals 4 squared. Break this down to get A by itself. A plus 1 equals 16. A is 15. A squared is 15 and A is the square root of 15. Now we're asked to find cos. Well, cos of x, I'll just bring up the page I had on previously. Remember SOHCAHTOA, cos is A on H. All right, so that means cos of x is equal to A on H. A corresponds with root 15 and H corresponds with 4. And in this region, all trig ratios are positive, and so we don't need to write a negative there. We'll just write in this region, so therefore that's the, it's positive because of this constraint. Very good. Let's move on to D then. Find sin x and cos x given tan x is root 35. So we'll do this one here. This is question D. Find sin x and cos x given. So we have tan x is root 35. Now remember, tan is O on top of A. So this corresponds with O on top of A. Now we have a problem here. It's not much of a problem, but we go, this isn't a fraction. That's fine. We can make it a fraction by putting it on top of 1. Because root 35 is the same as root 35 on top of 1. So now we have O corresponding with A, right? Let's draw our right angled triangle. Here's theta, here's our right angle, here's the hypotenuse, adjacent, opposite. And so we've got O corresponds with root 35, and we have A corresponds with 1. So let's make a statement using Pythagoras' theorem. We'll have 1 squared plus root 35 squared equals H squared. Okay, A squared plus B squared is C squared. 1 squared plus root 35 squared is H squared. Let's break this down for H. We'll have 1 plus 35 is H squared. So we'll have 36 is H squared. And that means we square root both sides. We'll get H is plus or minus 6, isn't it? Could be positive 6, could be negative 6. The square root of 36 is 6. Okay, so that's our H value. And so now we're ready to answer what's the sine value and what's the cosine value. Now just on this one, we're in the third quadrant. All right, so we're constrained to pi to 3 pi on 2. We're talking about this region here. And in this region, both sine and cos are negative. So to answer our question then, sine of x is O on top of H. O is root 35. H is 6. Root 35 on 6. But sine is negative in this region. So we'll chuck the negative in front of it. And cos of x is A on H. So cos of x is going to be 1 on top of H is 6. But it's negative because x values are negative in this region as well. And then we'll just reference the region. So we find the solutions using the triangle procedure and state the solutions justified by the region. Excellent. So that is question 4 from applications of the unit circle. Let's move on then. We're on trigonometric functions. So let's have a look at this one here, and I'll maybe just try and answer some of these on the paper. So the first one here says state its amplitude. So the amplitude is the distance from the principal axis to a peak or trough, and the principal axis is the line that's exactly halfway between the peak and the trough. So you can see the peak and the trough here, so that means this is our principal axis. It's an invisible line about which the wave propagates itself. Now, we're asked to find the amplitude. That's the distance from the principal axis to a peak or from the principal axis to a trough. So if we go from -1 to +1, that's a distance of 2. And you can see here as well from -1 to -3, a distance of 2, which means our amplitude is 2. Okay, the period is the distance for one whole wavelength. So one whole wavelength means one whole peak plus one whole trough. And we can see one whole peak and one whole trough in 8 units. So the period is 8. State the coordinates of its first maximum point for positive x values. So positive x values means we're considering this region. Here's the maximum point. Okay, the x value is halfway between 0 and 4. So the x value is going to be 2. And the y value is +1. So that's going to be the coordinates of the first maximum point right here. What is the distance between successive maxima? So the distance between this maximum and this maximum point, it's going to be 8 units, all right? Because that is one whole period. Another way of defining period is peak to peak, or trough to trough, or one whole peak and one whole trough. So the distance between successive maxima, 8 units. And the equation of the principal axis then, what's the equation of this invisible line about which the wave is propagated? It's y equals -1. Okay, this line about which the function is propagated, y is -1. Very good. So that's question 1 there. Let's move on to question 2. We're talking about the general sine function. For these ones, I'd encourage you to use your calculator to help you. We've written draw freehand sketches. So a couple of things to make sure you've got. Firstly, we'll go into graph mode and we're going to sketch 3 sine of x. Now looking at that, I know 3 is the amplitude and we're graphing it from 0 to 4 pi. So what we'll do next is we'll go into V window and I'm going to set my x min as 0 and my x max as 4 pi. And for y min, well, I know it has an amplitude of 3. So that means it's going down 3 and it's going up 3. And so you can just change this a little bit to get some nice corresponding, to make sure you can see the graph properly. The other thing we should do as well is absolutely make sure your calculator, I'll show you what I did there, I press shift menu, make sure your calculator is set in radians. 99% of everything you do in Year 12 mathematics is in radians. I've never seen a question in degrees, although it is stated in the curriculum statement. Okay, so there's that first graph, 3 sine of t. We expect 1 wavelength in 2 pi, 2 wavelengths in 4 pi, minus 3 sine t, that's just going to invert it. Maybe I'll just talk about these ones quickly. Like if we have sine of 2t, okay, this number b, that tells you how many waves would occur in 2 pi. So we would have 2 wavelengths in 2 pi. If we have sine of t on 2, like we do in C, that's the same as, I'm going to cross this out, that's the same as sine of half times t. Whenever you see this, t on top of 2, always think of it like this, pull that number out the front. And that means there's half of a wavelength in 2 pi. So that means we expect it to have 1 whole wavelength in 4 pi. 1 whole wavelength in 4 pi because we have half of a wavelength in 2 pi. What is 2 pi? 6.28. Really good. So I'll leave you to do the rest of those just using your calculator to support you. Let's move on to the last question then, which is question 3. And here we're finding the equation of graphs. And they're all cosine functions. So we're told that. Now this is a skill that you'll be told whether it's a sine or a cosine function if it's ever something you're assessed on. So what we can see straight away is the principal axis is the line 0. So all of these are going to have some form y equals a cos of bx plus d. We never ask ones that have horizontal translations because they do get a bit confusing as well. And so that means we need to determine the values of a, b, and d. Now, in order to answer d, we say, what's the vertical translation? How much has it been shifted up or shifted down? Well, the vertical translation is 0. The principal axis is y equals 0. So that means our value of d is 0 in this circumstance. Next, we'll find the amplitude. The amplitude is the distance from the principal axis to a peak or the principal axis to a trough. We have an amplitude of 3. And then b, there's a number of ways to think about this coefficient b. The best way is to say the number b is how many wavelengths are there in 2 pi. So if we have a look here, we have 1 whole wavelength, 2 whole wavelengths in 2 pi, which means the value of b is 2, which means the equation of this graph that satisfies these constraints is going to be 3 cos 2x, and then we have plus 0, so we don't need to write that. If you graph this in your calculator, it's going to produce the same graph we have here. Let's have a look at b. B is a little bit more tricky. So what we can see here, hopefully, is the principal axis. It's always halfway between a peak and a trough. So if we've got 6 and 2, what's halfway between there? We've got 4. So that was question A, 3A. Here's question 3B. So we have a principal axis of 4. The value of D is 4. The amplitude then is the distance from the principal axis to a peak or to a trough. That's going to be 2 units. And then the value of B is how many wavelengths are there in 2 pi? Well, what we can see is there's half a wavelength. There's one full wavelength in 4 pi. All right, if we go from a peak to a peak, that's a whole wavelength. One whole wavelength in 4 pi, which means there's half a wavelength in 2 pi. We have half a wavelength in 2 pi, and so the value of B is half. And so the equation for B would be y equals 2. So remember, it's y equals a cos. So we'll have 2 cos half x, and then plus 4 plus D. That would be for B. All right, on to C. C, we can see the value of D is 0. We have an amplitude of 2 units up, 2 units down. And then the period. The period's a little bit tricky for this one because we don't know where 2 pi is. So it's like, how are we going to answer this? Well, the formula for period, right? The formula for the period is 2 pi divided by B. 2 pi divided by B is equal to the period. And so if we have a look here, the period of this graph is from one whole peak to another whole peak. So from peak to peak is 10. The period is 10. So that means 2 pi divided by B equals 10. So if we're going to get B by itself using this equation, we're going to swap B and 10. We would have 2 pi on top of 10 is equal to B. What we're effectively doing, multiplying both sides by B, dividing both sides by 10. And so we've got B is 2 pi and 10. Can simplify as well. We could express it as pi on 5. We've determined the value of B using the period formula. So that means the equation for this one is going to be 2 cos of pi on 5 x. No vertical translation, so we don't need to plus anything to it. That's the equation for C. Okay, very last one. Excelente. So if we have a look here, all right, the first thing to notice about this one, I might talk about why it starts at the bottom last. We might get all of the other stuff in order, and then I'll talk about what's going on with that starting at the bottom. So we can see the principal axis again is 0. So that means for D here, the value of D is 0. There's no vertical translation upwards. We have an amplitude of 4, right? Distance from the principal axis to a peak is 4 units. And we can also see we have a period of 4. So from trough to trough, that's 4 units. Or from peak to peak, it's a little bit more ambiguous, but that's going to be 4 units as well. So the value of 2 pi doesn't feature. We can't use that first strategy, so we have to use the second one, right? The period, 2 pi divided by B, is equal to 4 units. So we'll swap B and 4. We'll have 2 pi on 4 equals B, and this simplifies to pi on 2. The value of B is pi on 2. So that means the equation of this one would be 4 cos of pi on 2 x. Now, if you graph it, it's not actually going to match up. If you graph it, I'm going to sketch it for you now. Let's do that. We've got 4 cos of 2 pi on 2 x. And we'll set our V window the same. So let's just go from 0 to 8-ish. And for y from -5 to 5, so we can see it nicely. All right, it's not the same. Here it's starting at the bottom, here it's starting at the top. And in fact, what these functions are is they're the flip of one another, they're the negative of one another. So if I just chuck a negative in front of that, all right, now we've got the solution. What we're doing is we've made the positive values negative and we've made the negative values positive. We've flipped it, we've provided the mirror reflection. So that means for our answer here, we just need a negative in front of it to get the final solution. So excellent work. That's wrapping up the trig. That's wrapping up the holiday homework booklet. So hopefully all makes a bit of sense. If you have any questions in particular, send an email, leave a comment. I'm happy to provide more detail on a particular part if you need it.